Yeah, good morning, Sima.
Good morning, sir. As I
Yeah,
told you, I miss the sessions.
okay. Yes. So, I mean, are you able to receive the recordings?
Yeah, for 2 days I got it.
Yeah. For today and
Yeah.
tomorrow, I think by Monday or Tuesday it will be sent.
Okay, sir. Okay, sir. No problem.
But let me know in case you face any issues. Maybe you can connect after the FDP also.
Yes, sir. Yes, sir.
Yeah.
I have to go through all the sessions and then I'll
Yes.
connect to you again.
And so hopefully today you are able to attend.
Yes, sir. But not sure about what is going on.
Okay. ठीक है. So
Yeah, because
actually,
I miss totally the afternoon session. So
yeah. So maybe you can join during the project discussion. That will help you.
okay, sir.
I think your group member is Harsh, right?
Sir, I don't have any idea because
Okay.
I miss it. So
Acha, right.
I'm not sure I will be do it or not.
Okay, no problem. But
Yeah,
at least you can
yeah.
see what people have done so that at least you get an idea.
Yes.
It will help you to understand.
Yeah. Sure, sir. Thank you, sir.
Yeah, sure. Yeah, good morning, Barka.
Good morning, sir.
So you are able to do something now? I mean,
Not yet, sir. Actually, I was trying for the ARMA modeling.
acha.
I have tested for the AR models and MA models, but for AR, MA, ARMA, as we have to test the lag identification through
Yes.
EACF, but I am getting an error. So,
Okay, right. So will you be able to solve it or you want me to help you?
I want you to help me.
Okay, no issue. Just can you share your screen? Let me see.
Yes, sir, I'm sharing. Here it is, line number 1 to 9.
So run this. Okay. Do one thing. Missing values are there or not? Have you checked that?
No, sir, there are no missing values. Actually, we have created this variable yesterday, Cipla return 123 after
Right.
data framing. Yes, sir. So there is
So
no
in
missing.
line number 129, you try with this thing after EACF bracket, after EACF, then
Yes, sir.
bracket. Inside the bracket.
Inside the.
No. Just
Okay.
Then write as dot numeric. No. Simply type as dot numeric.
And now put the bracket.
Type then bracket and close the bracket here. Last. Now run this. Okay, let me see what is the data type view your head.
Sorry, sir. Didn't
Head
get-
simpler return 1 to 3, you write head.
Yes, sir.
Type
Head.
head.
Okay.
Just let me see the observation data. So there is no output for this also. Can you go back to where you have computed
Created this variable.
Huh?
So you want me to go back to that variable where we have created this simpler return one?
That variable where you have created, let me see. 1, 2, 3.
Here it is, sir, in line number 17.
Okay. Type you execute line number 1, 3, 13.
So my system is slow.
I think here also it's not working. Line number 9, you just try. Line number 9 first.
Actually, sir, in the console window, there is no error coming. Oh, sorry, arrow.
That's
So
okay. You press escape button.
Yes, sir.
Press escape first.
I'm pressing, but I think this is taking time.
Okay.
So I will have some more questions.
I
May
think
ask?
actually, Sipla actually you have taken C capital and small both.
So it's working now.
Return is coming, right? Simpler return is coming. And you go to, okay, then just type EACF in line number 6, you type line number 6. You type EACF. Then Sipla underscore return. Now execute this.
I think the C has to be capital, sir.
No, she has created with small letter only. Sipla return could not be found. C capital here it will be. In this case, it will be capital C.
Yes, capital C.
Missing values are there. Okay. Sipla return कहाँ आपने calculate किया? Okay, 12 में line number 12 में -1 करिए bracket के बाद. After the bracket, give a square bracket.
Sir, in which line number?
1, 1, 2, 1, 12.
Oh.
Execute this line. And then again, EACF. It's taking time for your computer to calculate.
I don't know why it is taking time while I'm sharing my screen. Otherwise, it's working too fast.
Okay. No problem. I think. Are you using a LAN connection or your Wi-Fi?
With my mobile, sir, I don't have good connection today.
Mobile will be a problem, that's why. Because the speed will be an issue.
Okay, sir.
No, but for this you don't require it. For this you don't require an internet connection because this is an internal command going on. So computer, I think you need to
update our studio.
No, our studio is working well. Maybe the computer is processing is very slow. So maybe you can ask some of the IT person. It is now able to show you.
Yes,
missing
sir.
values are still there. Okay. So first you try to remove this missing values. You do one thing. Simpler return कहाँ पर है? Okay, diff में. Okay, line number 12 में after equal sign you write na dot omit. After equal sign. na dot omit, then bracket. And after one, this one you remove. This one you remove now. Now run this. Okay, now ESCF, simpler return, line number 6. So missing values क्यों आ रहा है? I don't know. No, that's okay.
I'm just checking if in this case also it is showing error or not.
I think in line number 2, you do one thing.
Yes, sir.
Line number 2, come to the at the end of the command. Let me see. Just before comparison, you press enter, only enter, just before comparison, after comma sign. जहां से कंपैरिजन स्टार्ट हो रहा है,
Yes, sir.
हाँ इक्वल साइन, नहीं, हाँ एंटर, ओनली एंटर.
Sir, before equal sign or before C of
नहीं, ठीक है, अब ठीक है, just press enter, that's all. नहीं, control enter नहीं, only enter. This line will come to the next line. So actually, we can see that. So here you write after zoo you write comma. Write quote, QUOTE equals double quotation ADJ, A capital A, DJ, then capital C, LOSE, close, SE. Now you run this. Now नहीं ठीक है, that's okay. ये सिप्ला प्राइस आ गया, राइट. नहीं, सिप्ला रिटर्न कहाँ पर है? लाइन नंबर 13 you have run.
Yes, sir.
नहीं, सिप्ला प्राइस में ये गड़बड़ हो गया. लॉग में जहां लिखा ना लाइन नंबर 13, लॉग के बाद सिप्ला प्राइस लिखा होगा, उसको डिलीट करना आपको. लॉग्स, डिलीट दैट फर्स्ट. Then you type Cipla, start typing Cipla. Capital C. Now you run this.
Only with Cipla.
That's all. Execute this line.
Now to do ESCF.
Now, ESCF में you run.
Yes, sir.
That's right. ठीक है, do one thing, you send me this particular command to in the chat box. Let me copy it. And,
so line number 2.
line number entire command you send it to me.
Okay, sir.
So you can share that with me in the chat box. Okay, so yeah, good morning, madam.
Morning. Can you, which were the packages that we had to load? There was an issue in my terminal yesterday.
Today,
Yeah.
TSDYN.
So sorry, come again.
TSDYN.
Okay.
And what else? URCA that I have given you. MTS.
Okay.
And what else? MTS is good enough. Var we are
You said frequency connectedness, spillover.
spillover also you need to install.
Any other ones?
No, not as of now. So I think
Okay.
it will do for us for the day.
Oh, perfect. Thank you.
Right, great. So, but any question so far regarding the concept?
No.
Sir, I have some
yeah.
questions.
Go ahead, go ahead.
Okay. So, while I was checking for the modeling ARMA, as you suggested, we have to see RMSE and MA. But in
Right.
certain cases, there is written NAN. Why is it so?
It is not able to calculate RMSE, so maybe the reporting issue is there. So
Okay,
maybe you can do one thing. You can, if your log likelihood is getting reported, then pick that particular value
Yes, sir. Yes, sir.
and maximize. I mean, you take the maximum value.
Yes, sir. And the second question is, first we have to check for AR models, then for MA, and first we should look into these two models.
Right,
And
right.
if we can,
ARMA becomes a
if
complicated
Yes.
model, so ARMA should be avoided in any case. But if it doesn't happen, so ARMA, yes, not very higher lags, maybe 1 and 2 or 2 and 1 should work for you.
Okay. And sir, what if T statistics is not significant, although the model is fit?
No, that means that coefficient will not be stable, right? So
Okay.
even if you pick that model, then still you may not get a correct predictions. So your main variable has to be statistically significant, which is important.
So we should
Model
look
fit.
for other lags in that case.
So maybe you can check with other lags, and the coefficient of interest must be statistically significant. Yeah. And that
Okay,
is what
sir.
we do. Otherwise, it will not have any implication.
Yes, sir.
So that, yeah.
So last session is in the last session yesterday, we have did the symmetrical guards, E guards, then GGR guards.
Yes, yes.
So and in NTPC return we find that there is no leverage effect. So I just want to ask, is there any direct method to check there is leverage effect in the data or not, or we have to run these models?
These codes you have to, these codes you need to identify.
Okay.
So what best you can do, just go for first you fit the guards model with using a E guards or your GGR guard just to check whether leverage effect is present or not.
Okay, sir. Okay, thank you, sir.
Right. So any other question?
Sorry,
Yeah.
Santanu, in the chat box, can you just give me the commands for the VAR, please? That did not get saved. I had an issue like this in last.
Right. Let me. Okay, this one. Yeah, I've sent it.
Okay, thank you. Thank you so much.
Right. So today we are we'll take a quick recap of what we have done so far up till VAR, and then we'll proceed with our VECM and the BEC model, and we'll talk about the spillover because I just wanted you to understand that spillovers are nowadays it's one of the contemporary technique by which you understand spillover of volatility and returns across asset markets. So maybe so that I thought, let me just give you an idea about the spillover effect and how to calculate and what are the implications. So maybe you'll be in a position to write maybe a research paper and submit to a journal, right? Although many other techniques are there, but spillover is a very accepted technique. So I will not get into the mathematics of this, but I will tell you the output, the interpretation part, right, which is more important for you. And the standard expressions are available, so maybe you can take the expressions from there, but interpretation will be very important for you. Right. Similarly, we are going to talk about the BEC model and the VECM model today. Although Beck model is a very complicated model again, right? So maybe let me just show you. So what happens is that Beck model is basically an extension, or you can say it is a Garch model in the multivariate setting, right? So it is used for volatility modeling for multiple assets. For single assets, we have seen that yes, Garch can be used. But the problem with Beck model is that it is a highly complicated model, and the interpretation of terms becomes very, very questionable at times, right? So there are many other improvements over the Beck model nowadays. So maybe if you independently can learn about those things, that will help you. So just let me give you an idea about the Beck model. As I told you that these models are very complicated in the sense that both EWMA is not complicated, but then it's not very robust method to start with, right? But still you should know how to evaluate volatility from here. This model is very complicated. It's an extension of the pure IMI model only. So today, if you, maybe after the FDP, you should learn about a new method that is, you can say it is an improvement over the Beck model, which is called as Shklersky decomposition. Right, so this technique also you can use, and it is more robust as compared to Beck model because it estimates only few parameters to do the multivariate modeling. Right, so that is the concept just I wanted to tell you. Okay, so yesterday we were talking about the bar part. First, let me complete that model. And we have identified lag number 8, if I am remembering correctly, for NTPC and Bajaj. For
Okay,
bar
sorry, just before that, my command var model is equal to var Bajaj NTPC red. That's not working. P is equal to 8 type.
Acha. Let me see your screen, ma'am. Let me see.
Yeah.
Which line is not working? The 790.
790. Yeah.
Okay. Do one thing. Run line number 782 first. And then you run line number 789. 790. Yeah. Okay. Error in var. Unused argument. Okay, you remove this type part. Type is equal to constant you have written, just remove that part. Up to p is equal to 8 you write. Let's see. What is happening? Let's check. Command seems to be okay. Okay. What select is working? 784.
Yeah, that's good.
I think this is working. I mean, there is no issue with the data. Okay. Do one thing. In line number 792, you write var underscore model. Is equal to VAR. No, capital V, capital A, capital R. In the list, it is right. So, the second, no, not the second. No. That is where the mistake is.
Yeah.
No, go at the bottom. Maybe another var. Under library, vars you have to select. It is selecting from
This
MTS.
is
No, just bit scroll down. Scroll
under.
down. No, scroll down further. So, scroll down. Scroll down. Maybe var you have to select from the vars. Okay, do one thing. That double colon last one. No, last one. Just select that. And from here you just type VV.
VV.
Only V. No, only V. Select the second option. Now you run Bajaj underscore. Select the first option. Second option, ठीक है. Then comma. Lag P is equal to 8, I suppose. No, P is equal to 8.
No, sorry.
Lag, identifying, we have identified lag number 8. So P, small p. No. Lag you do, just type P is equal to 8. No, don't write lag. P is equal to 8.
Equal to 8.
Comma. Type is equal to double quote const. Now you run this. And then you 793. So now it's running. I think now you can go for serial test. It's there also. That command is also there.
Right. Thank you.
See whether serial correlation is line number 791. You run that. So p value is more than 5%. So you accept the null of no autocorrelation.
Right. Okay.
So that means this model is good.
Yeah.
So let us do some more analysis on this result that you have got. So what we can do basically now, we can understand the impact of Bajaj return and NTPC return, their shocks. So that we identify using what is called as the impulse response function. Impulse response function. So what it basically does, it estimates the effect of.
Please share your screen.
Sir, I'm not sharing. Oh. So next is the impulse response function. So what basically it does, it estimates the effect of shock of the explanatory variable on the dependent variable. And how long the effect is likely to persist. Right. So this is the objective of plotting the impulse response function. Right. So, for example, it's a variable say x, which is a function of say y. That means y is my explanatory variable and x is my dependent variable. So I want to understand that what is the impact of this y on x, and if there is a shock given to this y, and how long it is going to affect in its own value. So graphs you will be able to plot. And suppose this is my time period, this is my time period. So you'll be getting a graph something like this. and you'll be getting a graph something like this, maybe. So it is y on y, and maybe say y on x. That means what? If a shock at t is equal to 0 is given to series y, then how long it is likely to continue? So we can estimate fairly that, okay, if it is 6 days or 7 days or whatever. So how long this particular shock will likely to persist in its own value? And if y and x are related to each other, then how the value of y or how the shock given to y will also affect simultaneously x, and how long it will continue. For example, I want to see if there is a shock given to NTPC's return. Does it affect the Bajaj return anyway? Right. And if it does, then to what extent? What is the persistence of that particular shock? So that is the role of this impulse response function. Right. So I hope the concept is clear. I mean, what we are going to do now.
Yes, sir.
Yes, sir.
Great. So let us plot it with our data set. Maybe you can write impulse response is equal to, just type IRF, and I think Bajaj, the common variable underscore rect. What happened? Okay, no problem. Internal response function of var model, because model we have estimated. Okay. And then we can see plot impulse response. So this graph will be plotted. Okay, this model you will be able to see. Are you getting the two graphs? Okay. You just maximize your graph if you have got it. Are you able to get this this graph, impulse response?
Yeah.
Okay, great. So you see at the top it is written orthogonal response from Bajaj Finance.
Sir,
So yeah,
in my case, it is showing figure margins too large.
Acha. Can you share your screen? Okay. ठीक है, run line number 410411. And then you go for 409. Acha. The plot area on the right side, and no, in the plot area, bottom right. बॉटम राइट जहाँ प्लॉट आता है ना हमारा, ये राइट हैंड साइड में सी एक ब्रश साइन दिख रहा होगा वहाँ।
here.
नहीं वो प्लॉट में राइट हैंड साइड में एक्सपोर्ट के बाद एक ब्रश एक साइन दिख रहा है, आइकन ब्रश का। नहीं एक्सपोर्ट के राइट हैंड साइड में, एक्सपोर्ट के राइट हैंड साइड में और राइट हैंड साइड में एक ब्रश दिख रहा है।
Sorry.
हाँ, this one. Press this one. Now press yes. And now plot 409. 408, you just first calculate 408, you run once again. And 410, 411. Uh, 411. Then again plot. It is not coming. Okay, do one thing. You see the cursor here at the middle. There is a you say divider. You can see at the middle of your screen in the R platform.
Yes, sir.
एकदम मिडिल में आपको देखिए, जैसे मेरे स्क्रीन देखिए. Let me share my screen. Let me share my screen. I will show it to you. जैसे ये वाला दिख रहा है ना, ये this side. This you take it on the left side.
Okay, sir.
इसको हाँ मेरे ख्याल से वो स्पेस नहीं बना पा रहा है वो. इसको करने के बाद then you run this again. Just check.
Yes, sir. Working.
हाँ. Okay. Oh, what happened? I think in my system now it is not working. It's a problem. Okay. So the first graph you see, it is the shock when Bajaj Finance is being given. Then what is the impact? So the first graph is of Bajaj Finance itself, and the second graph is of NTPC. That means I am more interested in the second graph. That means if there is a change or if there is a shock given to Bajaj Finance stock, then how much effect it is making on the stock volatility of NTPC. I see that as compared to the first graph, the top graph, bottom graph is very slow. The slope is very gentle. Are you able to look at it? So higher the slope, जितना ज़्यादा steep होगा ये line, the steep means impact is very sharp. Since in NTPC's case, this slope is very gentle, so we can make a fair assessment that there is not much of an impact of Bajaj Finance on NTPC stock price. एक बार यहाँ जो shock दिया गया थोड़ा सा दिख रहा है, but this shock is not likely to continue for a long period of time, right? So that means you get an idea that yes, Bajaj Finance and NTPC, their volatility or their returns may not be very related to each other, right? So that is the interpretation of this particular graph. Is it clear?
Okay, but Shantanu, yesterday when we ran VAR, we saw that Bajaj was the dependent one and NTPC was the independent variable, right? Based on the adjusted R square. Here, why we seeing vice versa?
No, actually, R picks up the value as per one internal algorithm. So even if you take NTPC versus Bajaj, no, the response will be the similar, will be same.
This
So it is
plot
it
will
is
be
not
same.
it is not related to that particular equation or the model that you have identified. It is basically just it is showing that what is the relationship between these two stocks.
So can I interpret it the other way also, that if there's a little bit of change in NTPC, the response, impulse response is much higher in Bajaj, since Bajaj.
No, because see the response is very gentle in both the cases. Right. So, but I don't know.
Go ahead.
But I don't know what is the impact of that particular NTPC you are saying, right?
Yeah.
Right. So in this case, what is happening here? Where is my graph?
Yeah.
Okay. Here it is. So it is saying that yes, the other way around, if you want to your establish. So we have identified in the previous case that I think NTPC was the dependent variable, right?
No, Bajaj was the dependent.
Bajaj was the
and,
dependent variable, right?
Yeah.
And you found that that model is working well.
Yeah,
Right?
correct.
So
Correct.
so that means that thing is already established. That NTPC
Okay.
is causing Bajaj Finance. That we
Hello. Hello. Did I lose you?
basically you can say it is a one-way causality. So NTPC is causing Bajaj Finance and not the other way around.
But the fair NTPC is causing Bajaj Finance. I got that. But in the impulse response, I thought you were telling us the other way around.
No, this response, this IRF, we are interpreting based on the output that we have got.
Okay, fair.
Right. So first model you have selected yesterday, and you say that yes, NTPC return has an impact on my Bajaj Finance. That is established. But I want to see the other way around. That does Bajaj Finance also affect the volatility or the risk of NTPC? So we are finding that it is a very gentle relationship.
Okay.
So the causality is flowing from NTPC to Bajaj Finance and not the other way around.
Okay, fair. Yeah.
So that is I mean, so Granger causality also you do many a times to understand this.
Sir.
Yeah.
So can we get these impulse response graphs for the other way, like NTPC impacting?
No, it will not do, because it is selecting the first model. And it is right. First model is NTPC is I think dependent on Bajaj Finance.
No, sir. First model was Bajaj Finance is dependent on NTPC.
First was Bajaj Finance was so NTPC to Bajaj Finance, right?
Yes, sir.
So that we have already selected. So that model is already selected for us, right? Because the adjusted R-square value was higher in that case.
Yes, sir.
So that means
but we are getting these impulse response graphs for the second model.
For the second part, yeah.
So yeah, I think Barkar, my question is the same. The model that is getting established is that NTPC has an impact on Bajaj Finance, right?
Finance, yeah.
But impulse response is showing that with changes in Bajaj Finance, NTPC does not get affected much.
Right. And so basically, see, in Granger causality, what you do? In Granger causality, you try to establish the causality from one variable to another.
And we run both in that then.
Right, and you run the both, right? And you identify which one is causing more, and based on the statistics. So whether X is causing Y or Y is causing X, that is what you identify from there. So VAR is also doing the same thing. It is, you remember that it is based on two system of equations. X is a function of Y and Y is a function of X. And you are identifying any one of them, which is causing what. So you are saying that NTPC is causing Bajaj Finance. So it's not the other way around.
Okay.
Right. So that is the interpretation of this analysis. So this impulse function is just an additional say metric that you want to confirm that yes, NTPC is really affecting Bajaj Finance and not Bajaj Finance is not affecting NTPC. So that is
assume that as per the adjusted R-square, yesterday, if we had got that NTPC was getting affected by Bajaj Finance, then would this impulse response give us
would have been
same
opposite?
It would have been opposite, is it?
Right.
Okay.
Yes.
Okay.
Right? So it is basically the Granger causality we do, and this is VAR is also doing the same thing, just to give you the directional relationship. That's all. Okay, so okay, so let me just quickly do the entire thing that we have done in the last session, so that you get control over the sequence. So let me pick any company, any other company of your choice. Maybe let's say, can you give me any company? Let me take Bajaj Finance. We have taken. Okay, let's take Asian Paints today. Ticker symbol is asianpaint.ns, and from now we will take a very long time period, maybe say 2005. It is 8th August, right? August till 25th. So from 25th of August, let's pick the data and let's quickly do. Okay. So we are doing a univariate analysis. So what you can do is just write Asian underscore red. You can write diff log Asian paint -1. So directly we have calculated the written part. And remove missing values if any. Asian Paints is equal to NA dot omit Asian return.
Sorry,
Yeah.
Shantanu.
Yes.
Can you run your graph again? Actually, then both graphs come up. I'm sorry, it just happened by fluke. Can you run that graph again?
This impulse response.
The command again. I don't know. Maybe we'll
This
figure
one.
out some- I'm sorry. Yeah.
Should I send it to you?
No. Just run it on your screen.
Okay. First we run this one to fit the model, to fit the graph.
Correct.
Then we are plotting it.
So plot it.
It has come.
Yeah.
This
Now
one.
it says hit. Yeah, fair. Go back to your commands.
Okay.
Command. Move out of this screen. So this is orthogonal impulse response from Bajaj Finance, right?
Right.
Okay, come back to your original screen. Yeah. And so in the lower left quadrant, the moment you do a hit, enter, lower left quadrant.
Any plot you're saying?
Yeah. Hit return to see next plot, right? So just do an enter there. I think the graph changes, does it?
It remains the same. It is again the same thing. Let me just.
Mine. Okay, mine changed. Okay, maybe offline. I'll take it with you then.
It is the same graph again.
Achha, okay, fair. I think why in mine it changed. Okay, fair.
Okay.
Right. Sorry. Come back.
नहीं,
Yeah.
कोई इशू नहीं. So Asian return we have identified. Let's say just see plot whether it is stationary. So visual inspection you can do Asian underscore red, and type is equal to a line graph. Here are
Can
in
you
plot
just
one.
Scroll up. Can you just scroll up? I'm sorry, I missed it in the beginning. Get symbols. Can you just scroll up?
Yes, yes.
No, go.
This one?
No, yeah.
Which one? We have started from here only.
Yeah,
Achha,
yeah. Just hold it there.
Okay, okay, sure.
Sir, can you please give this commands in chat box?
हाँ एक मिनट मैं दे रहा हूँ. Okay. हाँ, let me give you the command in the chat box. See, so you can directly type it fast so that. So let's go by one, stepwise. The first thing that we do is to report the Jarkevera test. Right. So first is normality test. So Asian underscore red. So data is not normal. So normality is rejected. That means we can go ahead with our ARMA models and all those. And step number 2, you have to test for the stationarity. So ADF test of Asian returns. So data is stationary. And what is the third step? So is to find the autocorrelation. So these 3 tests you must do before you proceed. So my box test. Up to say 10th lag we can identify, not required. So there is no autocorrelation. So this is another extreme example you are able to get. So what is my result here? Since no autocorrelation, cannot be modeled. So that is the conclusion you can write.
So when we check it at lag number 20, sometimes it is.
Yeah, we can check that also. No, it is still not there. At 10% it is there, but 10% we don't consider.
Yes, sir.
No, so this is basically a model which can, this is basically a series which cannot be modeled using the ARMA model. So in these kind of cases, what you should do, you should go for the conventional mean and the standard deviation. That's all. Right. So for the mean we have calculated whether I should go for modeling of the returns or not. So that is rejected. The return cannot be modeled using the ARMA model. And the second part is the risk part. Right. So test for clustering in the data. That is the risk part that we are going to test, because data is stationary and seems to that some of the clusters are present. So we can test that also through arch test, LM test of Asian return. So here it is rejecting the null hypothesis. Result is significant arch effect is present. So these are the sequence you have to follow. So I will write the final model also as in a table so that you can understand how to report and write in a research paper also for Asian paints. ठीक है, यहाँ तक हो गया? So I am saying that yes, significant arch effect is present. That means go for Gauge family models. That means you have to select the appropriate Gauge model. Are you done up to this part? Asian underscore spec, or I can write spec 4. Spec 4. So first we'll start with the symmetric Gauge model. ARMA order is 0, 0 in this case because no order is required. So here you put 0, 0. So this is the change you have to make.
No, come again. What was that?
See, in this case, in autocorrelation, we did not find any autocorrelation. This result is
Right.
Right. So
Achha,
since autocorrelation is not present, so we cannot model the return series using ARMA model, AR, MA, or ARMA. It's not required.
Oh.
Right. So that means since ARMA is not required, so here you put ARMA 0, 0. That's all. And as usual, we'll start with Gauge 1 model. So let us run this line first. Specification 4 and Gauge fit 4. Maybe we can write specification 4. I should change. And data is equal to Asian returns. Test the residuals also. So you can see the result. Guards fit 4. So you can check your results also. Okay. And here you have to type norm. Okay, just check you are getting this result or not.
Yes, sir.
Okay, so mu. So this is my mean model. And the last 3 parameters are my variance model. So let us see whether arch effect is present in the residuals or not, because that is the purpose of this model. So what you will do, go to the squared residuals, LM test. Here it is. So what is your observation? The right, any one of them you can go for. So it says that there is no arch effect present in the residual. That means the model that you have selected is appropriate for capturing the volatility clusters. Niblum statistics except alpha 1, which is the arch parameter. All other parameters are stable. It is slightly less than or more than 0.47. So that means you can write this model is able to capture this
Can
model
you
is able
just
to,
give the GuardFit4 command in the chat box, please?
sure.
615.
Yes, yes, sure.
So,
Yeah.
sir, although I have changed the ARMA order from 20 to 00,
Uh-huh.
yes, sir. But R is still taking the order 20.
No, I
I-
think you have to run it again. Memory उसका clear नहीं हुआ लग रहा है.
Okay,
You run line specification 4 once again.
okay, sir.
Check. Okay, so let me write the final model that you are getting. So this is my final model, and all the coefficients are highly statistically significant. Right, so that is what we wanted. So how this model will look like? So you can write the final model as, for Asian trains, the model that you have selected is Garth 1-1 model and mean model. Right, so here ARMA order is 0 in this case. So how will you write report? So first is the mean equation. So mean is simply equal to whatever you have calculated from there. So it is equal to 0.0013. So it is equal to 0.0013. And then we can write the variance equation, which is omega alpha beta. So this also you can write with the respective t statistics. So here you can write the coefficient, the standard error, and you can check whether alpha plus beta is less than 1 or not. So that is also important. And so it is alpha plus beta. If you add these two numbers, it is approximately 0.86. Right, so which means that since it is less than 1, that condition is satisfied, but it should be close to 1, right? I mean, if it is more than 0.95 or 96, we say that yes, the volatility persistence is there. So since it is quite less, so volatility persistence is not much. So whenever there is a change in the volatility of this particular Asian prints, it does not carry forward for a long period of time. It quickly subsides. So that is what the interpretation is.
Sir, can you just repeat the interpretation?
Yeah. So since the persistence is basically equal to these two numbers, right? Alpha plus beta. So alpha plus beta in our case, the persistence parameter, since the persistence alpha plus beta is close to 0.86. It means the volatility is not persistent, which means that if volatility changes, it quickly subsides. Right, so it doesn't carry forward for a long period of time. Right, so whenever there is a change in the volatility, whether increase or decrease, that quickly subsides. That means they quickly converge to the long-term average, the long-term standard deviation. So that is the meaning of this one, the persistence parameter.
Okay, so thank you. Thank you.
Can you show the screens where you were writing the results?
Here it is.
No, the previous. No, where you were writing the results, the previous one, the Dutch, etc., on the word pad.
This one, okay. This one?
No, that alpha beta is.
Alpha
Yes.
plus beta.
Yeah.
This one, right?
No, previous one. Alpha.
Acha,
Acha.
okay.
Let him finish. Let him finish. Please.
So is it a thumb rule, sir? This alpha plus beta persistence for
Ah,
all
they will
these
al-
stocks?
Yes. They will always be less than 1. So there are certain models that say in case you get alpha plus beta equal to 1, then we can use a model called as arch in mean. Which is arch M model. Or you can use I-arch model. Integrated Garch model. But this is a very rare condition you will be able to find.
Yeah. Okay.
ठीक है?
Yeah.
Okay. This is how you can proceed with your modeling part. So this is in a nutshell we have discussed today, right? So if this is clear, this process is clear, now we are ready to move with the next part, that is our co-integration analysis. Right? Any question so far? Okay, so let me just talk about the BCM model first. Your co-integration to start with. Now, what happens that in a multivariate setting, in a multivariate modeling, we can use these two methods, right? The VAR which we have just seen, and the second is the VECM, the vector error correction model. Right? Now, this model, VAR is basically used to model short-term relationships. Whereas VECM is used for long-term relationships. Right. So now the thing is that long-term relationship may be used in the market that we normally use for pair trading strategies. I'm sure you must have idea some about pair trading strategies. Right? It is basically used for it is help you to understand the long-term relationship based on which you can go for the pair trading strategies. Right? So what happens that suppose there are two assets, say X and Y, right? and you find that yes, they are moving in certain direction like this, something like this, and it is moving something like this. So there seems to be some relation between these two assets. So what you can do here, maybe somewhere here you buy the asset particular, here you sell the asset, here you sell the asset, and here you buy the asset, right? Because you know the relationship, long-term relationship between these two. So you can make some profits from this particular strategy, right? This is called as a pair trading strategy. So if we are sure, and if we first we need to understand that yes, there is a long-term relationship, right? So how do we do that? So for that, we need to understand that the concept of co-integration. So co-integration is basically, it is giving you an idea about that whether the assets are co-integrated or not. There is a long-term relationship between them or not, right? And if it is there, then can we make some suitable combination of these two assets to predict the returns of the assets, of the two assets in hand or the more assets in hand? Yes or no, right? So what is the concept of this co-integration? Right. So let me first talk about that. So for understanding co-integration, we need to use the price series. By definition and by design, you know the price series are non-stationary. That we have discussed already. It is a return series that is stationary, right? So first we need to pick the price series. Let the two assets be say P1 and P2, Bajaj price and say NTPC price, right? We need to check whether P1 and P2 are stationary or not. In any case, you will be finding that it is a non-stationary model. So if P1 and P2 are non-stationary and their linear combination becomes stationary, then we say that the series is co-integrated. Right? So separately they are non-stationary, but when they are combined with each other, then they become stationary. So what we are going to test is that P1 is equal to maybe say alpha plus beta into P2 plus the error term, right? So how are we going to do this? So it is equal to then my error term is equal to P1 minus alpha minus beta into P2. So I need to test that whether this residual is now stationary or not. So this needs to be stationary. This needs to be stationary. So if the residuals become stationary, then we say that yes, the two series are integrated to the order of 1. Right? So we say that it is I1. Right? So if we find some evidence that yes, the series are co-integrated with each other, then we cannot use the VAR model. Then we have to go for VCM model. Right? So that is the conclusion that you can draw from this particular discussion. That if P1 and P2 are co-integrated, then use the VCM model, right? So then we can use the VCM model. So how we can write this? So let y1 and y2 are the respective returns of P1 and P2. They're the return series. Then my VCM will again be a set of equations, just like bar. It is also a set of equation, but it is written like this: y1 will be equal to alpha 11 plus beta 11 into y1 minus 1 plus beta 12. Second model, second variable, y2 t minus 1 plus maybe say theta 11 we can write into p1 minus say gamma p2 plus the error term of the first equation. Similarly, y2 t will be equal to alpha 22 plus beta 21 y1 t minus 1. It is plus beta 12. 2 1 is already done. It is beta 22. Beta 12. It is 22 y2 t minus 1 plus beta 22 into p2 minus gamma p2 p1 plus the error term. This is the VCM structure, right? And these two terms are called as the error correction terms. Error correction terms. Right? So the linear combination will be possible, but by including this error correction term, which takes into account the stationarity part. Just complete this and let me know when you're ready.
Done, sir.
Completed? Okay.
2 minutes, 2 minutes.
Yeah, take your time. No problem.
Yeah, done. Thanks.
Okay, great. Okay, any question? Okay, so if there is no question, then I think let me do it with the data. So for this, you will require this library ts dyn first, library tsdyn. This is the first library you require, and then second library urca. So the first thing that you have to do is to combine all the assets, in a common data frame. So that is the first step you have to do. So since we have Bajaj and of the price, right? Here you have to write the price series. So this way you can do this. Bajaj price you already have with you. So first let us write this line and create a price series of both the assets. So this you have to do first. So I'm giving you all the codes that you're supposed to run. So this is basically one method to identify whether co-integration is present or not. So let me give it to you. Please copy it from the chat box.
Sir, can we plot those combined values? Is it possible?
Which one? That Bajaj Finance, that's one you're saying?
Yeah, both together.
Yes, there is a function called as matplot. Here it is. That's equal to So this way you can do that. So there's a lot of difference in the prices. So what you can do, just take the log values.
Can we give different color? Is it possible?
It is in different. It will get plotted in different color only. See the first line, red color line is of NTPC. The prices are very, very less. Bajaj Finance is trading at some thousands of rupees. Right? That's why this mismatch of the scale is there.
Yeah.
So to deal with this problem, what you can do, take the log of this price of both.
Yeah.
Then you will be able to get it. So first thing that you have to do is let us run that particular regression that I have talked about. So this regression I need to first run this regression, right? So it could be either P1 or P2, doesn't matter, because we are talking about the co-integration. So it can be, if co-integration is present, so it can be present in both the ways. So that is why I am running a regression first. NTPC is my dependent variable and Bajaj price is my independent variable. So I have run this regression. I have extracted the residuals and I need to check whether volatility clusters are present in the data or not. If clustering is present in my return series, in my residuals, that means my model is not co-integrated, right? That is the first conclusion. So what is the null hypothesis of ADF test? So data is not stationary. Is not stationary. Right? So for co-integration to be present, we must reject S0 for residuals. So this you have to test.
Sir, ADF test is in which library?
Which one? ADF test, T series. No, ADF test is in FinTS. Library FinTS, this one. So do this ADF test. And what is the conclusion that you draw from this? So this is the p-value I'm getting. Just see in your screen how much you are getting. What is the p-value?
Sir, I am getting 0.84.
Okay, ठीक है. So what is your interpretation?
So we are accepting the null hypothesis.
So that means
Data is
you
not
are So that means you are accepting the null, means you are saying that there is data is still not stationary, right?
Yes.
That means there is a problem of unit root present.
Yes.
So what is the definition? The definition says that the linear combination must become stationary.
Yes.
But in this case, we are seeing that it is not. So that means co-integration is not present in the data. This is the first test we have done. Obviously, we'll be doing the Johannesson test after this. This is the first idea you can get whether the two series are co-integrated or not. So our conclusion from the first test, from the stationarity test of the residuals, is that data or the two series are not stationary. They are not co-integrated. Right? So that is the conclusion we can draw. Okay. Is it clear, the interpretation part of the analysis of the output?
Yes, sir.
Okay. Okay, so let's take some break of 15 minutes. Maybe 10 minutes we can do that. 11:40. Will it be okay, or you want 15 minutes?
No, 10 minutes will be fine.
10 minutes is okay, right? So
Yes.
let's meet at 11:40, and we'll start to finish off the things early, so that you can spare the time on Sunday at least, some of the time. ठीक है, चलिए. So let's meet at 11:40. It's 11:30 already. So ठीक है, चलिए. Okay, so I hope all of you are back. So can we start? Can we proceed from here?
Yeah, sure. We can go ahead.
Okay, so right, fine. So we have done the first test of your co-integration. Now let us look into the more robust technique, which is basically the Johannesson co-integration test, right? So let me first run that. I will share the code with you so that you can also run it parallelly. So Control C. Yeah, I've just shared. The code is ca.jo, right? So this will be my code, and as usual, we will first doing this co-integration test on the price series. Usual. So just run this line. Are you getting output similar to this one? So this table will be important for us.
Yeah, that's right. Numbers are slightly different, but that's the output is there. Yeah.
Okay, great. So
Are the others here? I don't know. Are the others here? Ria? Yeah.
Yes,
Yeah.
ma'am. Numbers are slightly different.
okay. So we are interested in this table first of all, right? So this value of R is basically the rank of the matrix, right? Now what happens is that's why they are denoted as R, right? For example, let me just give you an example of a rank, then probably you will be able to understand. Suppose I write a matrix like this, 2, 4, 6, 8, 32, and 48. For example, this is a matrix, right? No, it is 16. Let me write. It is 16. 24. This is a matrix, right? So what is our observation? That it is a 3/2 matrix, right? It is a 3/2 matrix. The rank of a matrix is basically that how many independent columns are there. For example, if you look into this column 1 and column 2, what you find that column 2 is nothing but 4 multiplied by column 1. Are you able to observe?
Yes.
Right. So that means column number 2 has been derived from column number 1 itself, and they are perfect. So they are directly linear to each other. In this case, we say that rank of a matrix will be equal to 1, because there is only one vector or one column which is independent. This one is the dependent column, right? So the rank of the matrix will be 1 in this case. And this is basically the orthogonality condition we check. Orthogonal means that column number 2 must be independent of column number 1. जिसको हम लोग multicollinearity भी बोलते हैं, right? In a multivariate setting. So multicollinearity means the elements of those matrices are actually not orthogonal to each other. So orthogonality condition is very important because it depicts that how many independent columns are there in the matrix, right? So in that output also, it is basically the same thing. The rank of a matrix it is showing. So this result.
Can you please repeat this orthogonal and multicollinearity?
See, multicollinearity means if you plot, suppose this is say x and this is y. Suppose I run a regression like this, x is equal to function of y, right? X is dependent on y. Now, what is the problem that I find that x is not orthogonal to, or y is not orthogonal to x. That means x and y are not independent, rather they are dependent. You see, 4 is 8, 4 is 16, 6 4 is 24.
Yes, sir.
I mean, the second column has been derived from the first column, or it is, you can say it is dependent on the first column, which will lead to the problem of multicollinearity. Multicollinearity का मतलब क्या है? When more variables have correlation, right?
Yes,
and
sir.
as such, you cannot make any kind of valuable predictions. So for making any valuable predictions, what you need to ensure that there must not be any multicollinearity in the data. So for example, if I get a matrix like 4, 6, 5, 9, 7. Now, I say that these two matrices are orthogonal. The answer is yes. Right? 2 into 5 by 2 is 2.5. But 9 by 4 is not 9 by 4 is not equal to 2.5. 7 by 6 is not equal to 2.5. That means there is not a common multiple which defines these two matrices, these two vectors. Then we can say that yes, these two vectors or these two columns are orthogonal. In a sense that the rank of a matrix in this case will be equal to 2. Right? So is it clear? I mean, what?
Yes, sir. Yes.
है ना? So orthogonal का मतलब है कि they are independent of each other. So let's go back to this one. R is equal to 0. The null hypothesis is that there is no co-integration. R is equal to 0 means there is no co-integration among the two variables. The test statistics is 5.9, which is below all the levels of table values. Normally we are testing at 5%. 5% value is 14.9. But my statistics, this is called the test statistics, right? This statistics is less than my table value. That means I must accept the null hypothesis in this case. So what is my null hypothesis? There is no co-integration. So it is the same result. Huh?
Sorry, could you repeat again?
Since the test statistics is less than the critical value at 5%, okay, we accept the null. We accept the null of no co-integration. And this is a verification. In the first result also you have identified the same thing, right? When you did a residual test. So you are coming to the same conclusion that Bajaj and NTPC, they do not have any co-integrating relationships.
Are these p-values 5.90, 12.91?
No, they are the lambda values, the t-statistics.
How we are accepting the null?
You are accepting the null, right?
Sir, how? This is not clear.
See, आप hypothesis में पढ़ते होंगे ना, जैसे hypothesis testing में. So what we do? Suppose now Now this is my confidence level, right? Suppose this is my confidence level, let's say 5%. And if your value is falling in this particular range, what do you say? This is my statistics and this is my critical values. Critical values mean triple values. So what do you observe here? My test statistics is more than my critical value. In this case, what you do? You reject null. But if your statistics is coming in this range, suppose test is here.
Then
Then test 2 is less than my critical value. In this case, what you do? You accept null. Right? So that is what you need to do. So in our case, how much is my value? 5 point, how much I am getting? 5.9. So my statistics is 5.9. It is 5.90. And my critical value is 14.90. So what are you doing? You are accepting the null. And what is the null hypothesis in this case? No co-integration is there in between the variables. So you are saying that yes, I am accepting the null that there is no co-integration. So this is the second step of verification through the Johannesson test. Am I clear?
Yes, sir.
Okay. So since there is no co-integrating relationship, so obviously VECM will not be applicable for this particular data set. ठीक है, यहाँ तक clear हो गया? Now yesterday I have sent. Huh?
Yes, sir, it's clear.
Okay. Now yesterday I have sent you one data set, I think, of treasury bills in an
yes,
Excel.
sir.
So can you? There are two series in that case. One is the 3-month treasury bill and another is a 1-year treasury bill. So can you identify whether co-integration is present or not? First you import the data. So you can use the clipboard function again. This treasury bill co-integration data I have shared with you. So select the entire data set. Press Ctrl C. And here you type my underscore data underscore co-integration is equal to read clipboard, this one, and press enter, control enter. So this is under
Which one did
library.
we, out of the two, which one did we have to take?
Out
Out of the two columns?
These two columns, both the columns.
All three, is it? Yeah.
Date is not required in any case, but yes, since it is there in the database,
Okay.
so we, yeah.
Okay.
So what do you observe from data missing? So maybe let me just check.
This is, sir, data in data types actually. It is showing
Data
that it's like a data in data type.
are you getting
One is
error
the
message?
weekly, another is one is a weekly. No.
Read clip underscore table TBL.
Yes.
This you have to use. So if you check the data, so this is what we have downloaded.
No, so once you copied the data, what did you do?
First you copy there, Control C you
Huh.
press,
Correct.
and then you come to R, cursor anywhere on this particular line, 641 in my case, and press run this particular line. Your data will be imported.
Okay.
That also you can check by typing this next line. This is under library clips here, clip R.
Yeah, got it.
Under this library, you'll be able to get. So are you able to download the or report the data?
Yes, sir.
Okay, so some missing values are there. There is a mismatch in the length dimension of the series. So let me just check first. Length of the first series, my data. Say this is the 3-month weekly return. So this length is 3462. And length of my data 3462, right? So length is same. So let me combine these two. So table underscore 3M underscore 1 year is equal to C bind this one first, comma, second one. Let us run them. And let us remove any missing values, if any. So what I can do, table is equal to na.omit. Again, table. So now your data is ready. So you can now do the test on this particular series. I'm just coming. Okay, so are you able to get the results? So what you can write summary.
No, give 2 minutes, 2 minutes. Just scroll up.
Yeah, good. Continue, no problem. Lengths are different. Okay. This coming. So okay, so let me share these results. Let me share the code with you. You can run. Yes, check your chat box. Yeah, what is the
But
output you are getting?
Shantanu, here also the test number.
Here also
Yeah,
you see.
here also the test value is less. Yeah.
Right, right. So your conclusion is that there is no co-integration between these two series as well.
Oh.
So you have to always start from the bottom. The last row, you have to start from the last row.
Yeah, yeah.
So 11.06 you are getting, which is less than the 5% value. So we can accept the null hypothesis. ठीक है, I hope you are able to do this on your own now. Okay. So,
Yeah, go ahead.
so there is another data set, inbuilt data set called as data Finland. Right, just type it like this, data Finland. It will automatically pop up on your screen because it is under library URCA. So it's an inbuilt data set for you. And it has 4 variables, right? The real money, the logarithm of real income, marginal interest rates, and inflation, right? So quarterly data is there. So what you have to do, just try to find out if co-integration is present among LR and say marginal interest rates. Right, so this is a simple thing that you can do. So can you quickly tell me the result? Yeah, so are you getting the results? So this is the first, you have to understand the correlation between LL, the first column, and the third column. So what you can do, summary, ca.go, then Finland, press a $sign, this one. You have to combine them first. LR, one underscore.
Sir,
Yeah,
from where we have taken this data, Finland?
this is in my screen, you see, you type this one, 707.
Yes, sir.
It is inbuilt data. It is there in R itself, in this library.
Okay.
In URCA library, it is there. It is for your practice, yeah.
So won't we check the length first? Because
Length means where?
of the data that's there in LRM1 and LM1.
I say you want to check the length?
Yeah, because I got an error. Yeah.
Okay, just type length and then Finland.
Acha, okay.
Then press a $sign.
Oh,
So select the variable, say LR M1 you want to select. So 106.
So there is a these two series are co-integrated.
Okay.
Yes, sir.
So both the series are 106. So first one comma, the third one. And here we can write. Oh, what is the problem? Dimension. Okay. Okay, you're getting the results. Let me just check. Here it is. So it is giving you an evidence of co-integration because the statistics is more than the 5% critical value. So that means these two series can be used under the VCM model. The next one, R less than equal to 1. That means it is saying that how many combinations are possible? I mean, should we go for one combination or should we have, because see, there are only two assets, so you have always, it will be less than 2, the rank of the matrix. It is not significant here, right? But it is also rejecting the null hypothesis of no integration. So it is saying that yes, some co-integration is present in the data. Right? So that means this can be modeled using the VCM method. Are you getting the similar results or all others? You can check.
No, my summary thing didn't run.
Acha, it's not running.
No.
Acha, let me see your screen. Okay. Can you run line number 1013 again? There is no problem. Summary, it's not working. Again, run this.
Okay,
Now it
fine.
is coming.
Yeah, thank you.
Okay. So just check these values.
Yes, sir.
So which means that there is co-integration between these two variables, right? So we are now ready to do and apply this VCM method, a VCM model on this particular data set. So for that, what you have to do, just type library tsdin and then you type VCM. You have to select the third option. And feed that data, the combined data, LRM1, and say lag is equal to, we'll start with lag number 1. Okay. So this is the output we are getting. So I will write this equation, but first to get the output, yeah, are you able to get this output?
Yes, sir.
Okay.
Yeah, that's right.
Right. So what you have done basically, you have first identified whether co-integration is present or not, and then you have fitted the VCM model. ECT is basically the error correction term, right? So how will you write this model then? It should be equal to, now see, the first one is equation Finland LRM1, right? So first equation is LRM1. it is equal to, let me write the intercept term first, the constant term which is 0.0083, and its standard error is also given in the bracket 0.00064, no 0.0064. ठीक है, so this is the intercept term. Then we have lagged term. What is the lagged term for LR M1? Just a second. Let me see. I have taken a snapshot of this one. Okay, so actually I've got the incomplete photograph. That's why. Okay. See the first value. Simultaneously, you can also write intercept I have written. So the interpretation is, let me write it here. So the first equation is of LR M1, money supply, which is function 0.0083, and then the lagged value of LR M1, right? So what is the value? The value of this is minus, right? So it is minus
0.5134.
5134 LR M1 T minus 1. And then you have ln MR T minus 1.
So it's positive plus
It is
0.1739.
9 LR
LNMR
MR T minus 1. This is the first set of equations. Second set is ln MR T. So it is T. It is equal to 0.0, no, intercept. ECT term you have to write. Let me write in red color. The ECT term is
0.0136.
0136. There is a 1 star. Right? 1 star means it is significant at 10%. So 1 star is significant at 10%, and 2 star is 5%, and 3 stars are 1%. Okay.
Sir,
Yeah.
in my case, these stars and bracket values is 0.0064. These are not coming.
नहीं आ रहा क्यों? Can you share the screen? नहीं है तो results. You are getting different values, you are saying, right?
No, sir, star and bracket values.
Acha, okay, do one thing. In line number 487, you before VCM you write summary.
Yes, sir.
Write summary. Bracket. Close the bracket at the end. Now run this. Okay, and what is the equation for this one? Finally, so first intercept term, which is minus
0.0055.
0.0055. This is a constant term. Okay. Then what is the next
Sir,
value?
minus 0.2539.
Minus 0.2539, which is significant 3% of L.
For LRM1 T minus.
LRM1 T minus 1. Then finally we have
Plus 0.2460.
0.246 ln mr T minus 1 plus the ECT term.
It's 0.0187.
0.0187, which is
Three
significant
stars.
of 1% significance. So this is 1% significant. 246 is significant. It is also significant at 1%. So this is the final model. So that means what you are finding that this particular term, in fact, all the terms in the second equation, so all the terms in the second equation are significant at 1%. Right? So that means I should pick this particular equation which says that now, so if ln mr is combined is a linear function of LRM1, then it will lead to, it can be used for prediction. So you are now saying that ln mr is basically a function of LRM1. So this one is my dependent variable, this one becomes my independent. So if I select this model, I will be able to predict the movements. ठीक है? So have you noted down the final model? So this is basically the long. So this model will help you to predict the long-term relationships between the two assets. Any question? Any more question than this? Yeah, Barkha, you have some question, I suppose? No.
Sir?
Yeah.
I have questions, sir.
Hmm.
So when you run the command for summary of VECM, so we have taken lag at 1. So how we have decided to take this lag?
That is an arbitrary value we have started with,
Okay.
right? So because that is the smallest possible lag again. So in case you don't find a significant relationship, then you can go for lag number 2. So it is an iteration you have to repeat. Huh?
Okay, sir. And second question is, so we just have to decide the model on the basis of significance of the coefficients,
Right, exactly.
or there are the other tests like to do autocorrelation test of residuals or
That test will also be satisfied. Na? So suppose you run this regression, you note down these values first, right?
Okay, sir.
Now what you will have to do, you will have to now run a regression using this particular model. Then you have to extract residual.
Okay, sir.
So let me see if I can do this for you. So can you tell me the values? Okay, it's बहुत difficult हो जाता है, एक बार इधर एक बार उधर ना.
Okay, I
Just a minute. Let me see how to do this. Okay, let me write a regression _2 is equal to LM. Okay, what is the dependent variable in your case? LMR, right?
LNMR.
LNMR.
LNMR, yes, sir.
LNMR is my dependent variable, and my independent variable is this equation. So first you have to write the values here. What is the first value, intercept term? Minus 0.0055, right?
Minus 0.
Minus the
55.
intercept minus
Yes, sir.
0.0055. Then what is the next term? It's plus.
It's minus, sir.
Minus 0.2539.
Yes, sir.
Minus 0.2539 multiplied by what?
LRM. LRM.
M1.
T
It's
minus
the
1.
lag number 1, right? So you have to
Yes,
write
sir.
minus 1. So it will select the first lag. Okay, what is the next number?
So plus 0.246.
0.246 multiplied by
It's LNMR at
LN
lag 1.
at lag number 1. What next?
Next is error correction terms.
How much
Plus
it is?
0.0187.
0.0187.
Yes, sir.
ठीक है, ये आपका इक्वेशन हो गया.
Yes, sir.
And data equals to write what is my data? That LRM1. This is my data. ठीक है.
Yes, sir.
What is the problem? तो माइनस तो ठीक है ये. This one. Okay, ठीक है, I got it. This will not be here. So you can write prediction of this one. To this. अनएक्सपेक्टेड ब्रैकेट, अच्छा ठीक है, इसको मैं देखता हूँ। मे बी दिस यू कैन ट्राई इन एक्सेल, वो थोड़ा इजी रहेगा वहाँ। So what you do here, write .csv. ठीक है, फर्स्ट इसको एक्सपोर्ट करके ना, देन लेट्स are you able to import your export this data in your folder? My case it's not coming. It should have been here itself. What is the issue? No. You can do one thing. Let me. I think I am not able to define the lag here. I will have to check what is the command for this. Finally, what you can do, just copy these numbers and you can do the same thing in Excel directly from the data. So maybe you can directly transport the data. ठीक है, let me just solve this for you. Maybe tomorrow I will be able to send it to you, right? I think there is some issue with the formatting here. I will send this results to you.
Okay, sir, no problem.
या तो इसको ऐसा कर सकते हैं कि you export this particular data फिनलैंड को,
Okay.
और उसमें से ये LR1 and इसको एक्सट्रैक्ट कर लें, राइट? तो lag1 हमारे पास वहाँ डेटा में रहेगा. You just have to keep on multiplying these values. तो you will be getting a new series.
Yes, sir.
है ना? तो जैसे यहाँ हमने ओपन किया तो एक हमारा सीरीज आ जाएगा.
Yes,
ठीक है?
sir.
Predicted based on the model, and actual value is also given to you. Actual
Yes.
value of the dependent variable.
Yes, sir.
Compare the error.
The difference would be error.
हाँ, the difference will be error.
Yes. sir.
Error पे हम आर्च टेस्ट करके you can identify.
Okay.
तो उसके लिए क्या करेंगे? इसको you do this in Excel and import this table now into R. तो वहाँ हमारे पास error भी आ जाएगा.
Okay, sir.
And in that you perform this arch test, or right, so that is what we want. So there must not be any kind of clustering in the arcs of the residuals. If you're getting that, that means your model is perfect.
Sir, so what all we have to check for the residuals? Like
Residuals में
clustering-
arch test you have to do.
Okay, sir. Only arch test.
हाँ, this one we have done in the first half, right? This one
Yes, sir. Yes, sir.
here. So on the residuals only you have to run, right?
Yes, sir.
So what is the null hypothesis of arch test? That is a unit problem, right? Data is not stationary. So you must be rejecting that null if your model is good. You can say that the model that you have identified can be used for prediction purpose. ठीक है, up to this part?
Yes, sir.
Great. Alternatively, let me just check another thing. X equals. And this way also you can check. Another thing that, sorry, 1.403. So this combination can also make the, if you want to just check as of now, you have to identify these eigenvectors from this table. आप table में देखिएगा eigenvector report हुआ होगा. Are you able to look at? in your table, just after the statistics table, you'll be able to find this one, the eigenvector table. Yeah, are you getting it?
No, sir.
तो इसमें ये summary, ये इसमें summary of ये Johnson test, you run this line again.
Okay. Okay, sir.
हाँ, इसको run करने के बाद this result will come wherein you have identified that yes, there is some co-integration. So this table will also help you to identify whether combining the two series will become stationary or not. So this is another way of checking, right? So what you can do here is, since the number of sample size is very less, so but still you can do this. So you have to first see this particular table, and at the top you are getting one eigenvalues.
No, where is it? We need to run it again. No.
Run this summary as ca.go.
Huh? Huh?
Run this line first. You will be getting these Johannesson test results.
Okay.
Are you getting that result?
Yes, sir.
सबसे ऊपर में देखिए आपको आइगन वैल्यूज दिख रहा होगा, लैम्डा ब्रैकेट में लिखा है.
Yes, sir.
The first
That's
eigenvalue,
right. Yeah.
हाँ, right. First eigenvalue is of LR M1. क्योंकि उसी सीक्वेंस में वो रिपोर्ट कर रहा है, सेम सीक्वेंस, जिस सीक्वेंस में हमने डेटा फ्रेम बनाया है. First eigenvalue is of LR M1. Now you have to, what you have to do, you have to identify out these two eigenvalues which one is higher. So we can see this one is the higher eigenvalue.
Yes, sir.
ठीक है, एक कॉलम है, उसके corresponding this value is reported, this one, and for this one the corresponding values is this one, this matrix or this column. So since I am getting a higher eigenvalue here, the first column, that means I have to select first values, first column values here. It suggests that if you combine these two numbers with the series, I should be getting a stable series, a stationary series. And that is what I have done in this line. See the first one, this value, आपको दिख रहा है ये?
Yes, sir.
है ना? ये M1 का value है ये.
Yes, sir.
What I have written 1 into M1. Plus the second one is ln MR. 403 multiplied by these two, ln MR.
Okay.
And I have put that in a variable say X, and I'm plotting it. This plotting is giving me a stable kind of relationship. This kind of graph you're getting just because the number of observations are very small here. But if you can see, it is moving in a parallel range. Right? There is no trend.
Yes, sir. Mean reverting plus variance is also
हाँ,
constant.
थोड़ा सा mean reversion आपको दिख रहा है यहाँ पर. So it is moving in a constant range, which suggests that it has become stationary. So this combination has become stationary. This way also you can check.
Okay, sir. So can you please share these commands in the chat box?
So this one?
Yes, sir.
Okay. ठीक है, so since your plot has become stationary, so you can finally conclude that yes, this combination will make my results stationary. Okay, so this is the VCM part. Okay, so can we now, let's do one thing. Let's do a similar exercise for now 3 stocks. Yesterday we had downloaded 3 stocks: Microsoft, Ford Motors, and Netflix, I suppose. So let me just recall that. So this price is already there with us. And let us do a stationarity test or integration test on this particular series. And let's identify how to interpret the results for now more than 2 stocks. Are you ready with the data?
Yes, sir.
Okay, others, Dr. Vemuri, I haven't heard you for long now.
Yes, sir. Yes, sir. I'm there.
Okay, great. Harsh, are you there today? I mean, I also did not get any kind of thing from your side. I think he's not there. Anyway.
Yeah, I'm here.
Okay, yes, fine, great. Chaliye, so let us do this Henderson test on the 3 stocks now. So write summary ca.go and then MSFT. Right, so this is my result. Just check your results. So here also you're getting, so the second column, second row is rejected here, right? And the first row is also rejected. That means there is an evidence of co-integration in the data, right? Which is very, very slight. I mean, slightly higher. It's not very strong.
Sir, so we just have to look at this R0.
R0, because these values are not significant. They are less than the table values.
But there should be some organic relationship, no? Then only we'll get that co-integration.
There has to be some relationship, yes, long-term
Yeah,
relationship.
yeah.
But we need to test it.
Yeah.
What kind of relation do you have?
I think this kind of exercise is good for predictive maintenance kind of a scenarios, I suppose.
Right, exactly.
Yeah. Actually, I'm just looking IoT related in case I do the time series, especially for the battery maintenance, like any in the EVs, in the electrical vehicles.
Right.
We have the information about the temperature and other conditions, physical parameters, and then we can look for the predictive maintenance of these things with respect to some outcomes.
Okay. So you have quarterly data, or what kind of?
I don't have the data, but I have seen such kind of a data.
Achha, right.
I mean, organically, there should be some natural relationship between these parameters.
Right. There has to be a long-term relation.
Yes, sir. Yes.
Great. So Yeah.
In case we found co-integration in the first series R2 or R1 and not in R0.
No, see, you have to go one by one. So if you find that yes, it is not actually it's not rejected, so go to the next one. Now, for example, here suppose the value is instead of 9, suppose the value is 19. This one. So interpretation क्या होता?
Sorry, sir. Actually, your voice was not audible.
Okay. Suppose the test status instead of 9.7, suppose the value would have been say 19.7.
Okay.
Right. So
So
that
here
means
we will be rejecting the null. That means the series are co-integrated.
series are co-integrated. Now, what this R is showing? R is showing that out of the two assets, out of the remaining two assets, you have to pick any one of the assets. Microsoft, see, first of all, you have to identify what is the eigenvalue, which one is having the maximum eigenvalue. Again, I am finding that the first value is having the maximum value.
Yes, sir.
0. उसके corresponding हमारे पास क्या Microsoft.
Microsoft.
That means Microsoft is my dependent variable in this case. So अब दो independent variable हमारे पास बच रहे हैं. One is Ford, one is Netflix.
Yes, sir.
ठीक है. यदि आपका वैल्यू सपोज यहाँ 19.7 आ रहा है,
हाँ जी.
इसका मतलब है कि आउट ऑफ these two you have to pick any one of the assets, not both. So you can select either Ford or you can select Netflix, but not both.
Okay, sir. So
For
it means
example,
Microsoft doesn't have the co-integration with both of the series.
नहीं वो तो टेस्ट करेंगे अभी तो.
Okay.
ये तो जैसे हमारे एक लीनियर कॉम्बिनेशन हम बनाएंगे डायरेक्टली.
Yes, sir. Yes, sir.
है ना?
Okay.
So that is how it has to be interpreted. So rank मतलब rank is basically how many vectors are orthogonal.
Okay, sir.
So Microsoft के साथ Ford return is orthogonal, for example. So orthogonal means they can be combined. They can be used in the regression. VCM is what? VCM is basically a linear regression. Right? And just as you do in your simple OLS, आप यहाँ ऊपर में देखिए शायद OLS लिखा होगा. They estimated by using OLS only. This VCM method. So in a OLS method, what you basically do, also you try to understand that yes, there must not be any multicollinearity among the data.
Yes, sir.
Right? Especially among the independent variables. So how will you understand that? So that you have to understand from the fact that yes, the vectors are orthogonal. Right? So orthogonal means दोनों के बीच में so suppose Microsoft का एक return है and Lambda का return, so they are not directly proportional to each other. ऐसा नहीं कि Microsoft का यदि 100 रुपीस प्राइस होगा तो इसका 110 हो गया, इसका यदि 200 होगा तो इसका 220 होगा, ऐसा नहीं है.
Okay, sir.
Right? So that means you can say that yes, Microsoft and Ford Motors, they are orthogonal to each other. So which means they can be included in the regression. So what you can try here is that this eigenvalue is the maximum. So you have to select the first column. First column का ये values हैं. 1, तो इसको आप करके देख लीजिए. Say yy is equal to 1 multiplied by Microsoft. Press a $sign Microsoft. Then minus 45 multiplied by Ford. Ford is this one. And again minus 0.57.
Sir, 45 multiply this $4. I think you forgot to write
अच्छा. Here. Ford. And this multiplied by MSFT price $sign Netflix. So this is my YY series. Let me just plot, see. So there is a lot of variation. Right? But this is only a visual inspection.
Shantanu, can you give the command in the chat box, please?
हाँ,
Why
हाँ,
is equal to?
sure. This one, na? Yeah. So this way you can identify the relationships.
Sir,
Yeah.
I actually got little bit confused. Can you please interpret these results again of Johansson test? So how do you decide to whether the series are co-integrated or not?
यहाँ ये first one is the null hypothesis of no integration, no
Yes,
co-integration.
Yes, sir.
ठीक है, किसी भी एसेट के बीच में co-integration नहीं, out of 3 मतलब it is permutations, Microsoft versus Ford, Ford versus Netflix, Netflix versus Microsoft.
Yes, sir.
It is one by one it is doing. It is saying that there is no correlation, but which you are rejecting.
Yes, sir. So it means series are co-integrated.
It's a co-integration, but if you look into the 5% value also,
Yes, sir.
you see that value is very, very close to this one.
Yes, sir.
मतलब you are not sure, क्योंकि इसमें fully ये reject नहीं हो, बहुत ही marginally it's higher.
Yes, sir.
So it's an indicator that yes, co-integration दिखा तो रहा है, but it may not be that strong a relationship.
Exactly.
Right. So even if you go for a linear combination of these 3 stocks, you may not get a stable and a stationary relation, which is reflected in the graph also.
Yes, sir.
Maybe आपको दिख रहा है, बहुत ज़्यादा variation दिख रहा है. Right.
Yes, sir.
So although it is moving again in a parallel direction, parallelly ये move कर रहा है, ऊपर downward upward trend नहीं show कर रहा है, which means that yes, stationary तो convert हुआ है, but हम यहाँ पर दिख रहा है data में. Right. So there is too much of a variation in the extreme right of this graph. So that's happening because of this particular value. So co-integration ka, there is evidence, but the evidence is very, very, very gentle and weak. So that is what I have done. So I have gone for a linear combination just to identify whether it is giving me a stable relationship. So I got this, some integration is there, but it's not very strong. Means for this kind of model, VECM may not be appropriate, so you can go ahead with VAR model only between these 3 stocks, because VECM may not be applicable for this set of data also. In case of inflation, you have seen that was strongly rejected, right?
Yes, sir.
तो उसमें हमको दिख रहा था that graph was very, very stable. But in this case, it is not happening. So that's mainly because this value 21.42 versus 21.07, slightly higher, marginally higher. So indicating a very, very weak co-integrating relationship.
Sir,
Yeah.
after concluding that none of the stock are co-integrated, then we run this command, this YY and plot. So please explain this interpretation.
See, this graph is telling you that after I combine these 2 series, so Microsoft return is not being predicted correctly, right? So there is a variation. That means this variation is basically showing that my residuals have not become stationary. So the condition is that when we combine these 3 assets, my residual from that equation, आपने कभी linear equation बनाया, right? 1 multiplied by something minus 0.45 something. तो एक linear regression बना हमारा. And from that regression, you are extracting the residuals, and that residual is getting plotted. So the idea is that a residual must not have any unit root. That must be stationary. So here you are able to see, yes, up to certain part it is stationary, just ये वाला part है, left hand side of this graph. But if you see the right hand side, it is exactly opposite. I mean, there is a huge variation.
Yes.
Are you able to locate it, right? So which is indicating that yes, some co-integration is there, but that co-integration is not strong enough to justify the use of VECM for this particular set of stocks. क्योंकि यहाँ एविडेंस है ही नहीं। जैसे LR M1 के केस में देयर वाज अ स्ट्रॉन्ग एविडेंस ऑफ को-इंटीग्रेशन, isn't it?
Yes.
So then you can go for the VCM model for your that LR M1 and that M2 inflation part. So, but we are not getting any evidence here. Is it clear?
Yes, sir. Now.
ठीक है। सपोज आपका यहाँ पर वैल्यू सपोज आता है 19.7 फॉर एग्जांपल, दिस R is equal to 2 के यहाँ पर, what would have been your null hypothesis rejection or acceptance? Suppose instead of 0.7 you would have got say 19.7 for example, then how will you interpret this number? You will reject null hypothesis,
There is co-integration.
right? So now co-integration है R is less than equal to 2, इसका मतलब है कि that also you are rejecting. अब आपके पास कितने वेरिएबल्स हैं? 3, ठीक है।
Yes, sir.
Microsoft, Ford and Netflix, there are 3 stocks are there, but R less than equal to 2 is also getting rejected, which is suggesting that the rank of this matrix is more than 2. That means all the 3 assets need to be considered for my linear combination.
So could you please repeat?
देखिए suppose R, ये वाला फर्स्ट टॉप वाला जो कॉलम है ना,
Yes, sir.
suppose instead of this 0.7 मैं इसको लिख के बताता हूँ so that it will be easy for you. अभी हमारा R less than equal to 2, suppose the test statistics would have been say 19.75 and my critical value is say कितना है इसमें critical value? हाँ 8.18. So my critical value is 8.18. That means you reject the null of less than 2 co-integrating variables. That means you should consider all 3 stocks for your linear combination. ठीक है, R is less than rejected. That means it is saying that R is more than equal to 2, more than 2. तो R का मतलब मैंने क्या बताया? रैंक. तो R is the more than 2 है, मतलब हमारे पास 3 assets आते हैं. That means all the 3 assets are orthogonal to each other. Right. So that means it is suggesting that you should include all of them in your model. So that is what the meaning.
Sir, it means all the 3 are orthogonal. That means all the 3
Yes.
are independent to each other. There is no co-integration relation.
Right. And they can, all the 3 should be included in your co-integrating relationship. यदि आपके पास 4 स्टॉक होगा तो कितने रैंक आएंगे? आपका रिजल्ट आएगा 3 तरीके का रिजल्ट आएगा, 4 रिजल्ट्स. यदि हमारे पास सपोज 4 स्टॉक्स आर देयर, तो हमारे पास क्या क्या रहेगा? 4 स्टॉक्स का मतलब n-1 आ जाएगा. तो n less than 3, less than equal to 2, less than equal to 1, less than equal to 0. 4 स्टॉक्स. 5 स्टॉक्स के लिए क्या हो जाएगा? less than equal to 3, less than equal to 2, less than equal to 1, less than equal to 0. This is for 5 stocks. And you continue. So suppose for example आप यहाँ reject for 5 stocks, suppose you reject at here also. So your conclusion that you need to include all the 5 stocks construct your linear combination. That means all the 5 stocks are orthogonal to each other. Is it clear?
So please show the last screen where you
Okay.
have written the interpretation.
Ah.
Yes, sir.
Sir, I think this will work for the foreign exchange much better.
Yes, they are likely to be co-integrated.
Integrated, yeah, yeah. Maybe we will give a try for such kind of exercise, sir.
Can you?
Commodity. We will give a try for the commodity trading kind of a scenario.
Yes.
And for foreign exchange, and then we'll try to publish something for your conference. In
Right.
case,
Please do
yeah.
that. That will be a good output also of this FDP.
Yeah. Actually, this co-integration is interesting, but I think it is better if we look for a commodity and foreign exchange.
True. Okay, so this part is clear. Any more question? Okay, so I think if there is no other question, I think we can take a break of for the lunch. Do you want me to start at 1:45? Will half an hour be okay for you so that we can finish early? Only one topic is remaining, the back and the spillover. Spillover only results I will discuss. So it should not take much of a time. 1:45, should it be okay for you?
Yes, sir. No problem.
Sure, we can start.
Okay. So let's just meet at 1:45 so that we can finish early and we'll discuss your final questions, question answers and all those things. Right, and your project also if you have done something. So let's discuss that also. Okay, let's meet at 1:45. It's 1:15 already. Let's have the lunch and come back. Yeah, so good afternoon. Hope all of you are back.
Yes, sir.
Yeah, great. I think. Okay, so can we start with the remaining two models? If there are no questions.
So,
Yeah.
So, sir, whether to apply VECM or not, so we just have to look at the R is equal to 0.
R is equal to 0 will tell you that yes, there is some co-integration in the data. But
Yes, sir. Or if data is not co-integrated, then we will not apply VECM.
no, then you go for var.
Okay, sir.
Huh.
And I can say R is equal to or less than 1 and less than equal to 2. They are just showing the co-integrating relationships. How many
Integration, so that means it is showing that how many variables, what is the rank of the matrix? Basically, that means if rank is less than equal to 2, you're rejecting, right?
Yes,
So
sir.
then you're concluding that your rank is more than 3, more than 2. If it is a 3 asset.
Yes, sir. More than 2.
More than 2. That means all the 3 assets need to be included in your regression model, the VCM model. So in other words, if you take, if you combine all the 3 assets, it will give you a stationary series. Is it clear?
Yes, sir, but I think today I'm just confused, so I'll see it again.
Okay. ठीक है, चलिए. Let's proceed to our next model. Which is our multivariate volatility models. So we are going to use 2 methods and the Beck model, right?
Can you share your screen? Yeah.
Oh, okay.
Are you using it? Yeah.
Okay, yeah. Just a second. That's visible.
Yeah.
So these 2 models we are going to use exponential weighted this model is actually due to the 4 authors who have proposed this model. I think it was somewhere given in 1996. And so these 2 models we are going to use for our volatility models. But we will see shortly that the computation of BEKK model is very, very time consuming, in the sense that even R will take some time to give you the output, right? So let us see what we get finally. So I will just discuss some of the basic ideas in this model, and right, both exponential weighted model and in your the BEKK model, right? So let us first talk about the exponential weighted average moving model, right? So let me write an equation first, then I will talk about that. First is EW model, right? So it can be written as it is equal to right? Where this is basically the variance covariance matrix. Error term is equal to matrix of residuals from the mean equation, and lambda is a constant which is 0.96. In most of the cases, we get a value of lambda of 0.96. It is empirically proven, so we can safely take this value, right? So the condition is that the 0 must be less than lambda, must be less than 1. So that is the condition of lambda. It is basically the persistence parameter. It measures the persistence parameter. Just like in Garch models, we have done alpha plus beta. So in a multivariate setting, this is taken for lambda, right? Now, since it is a multi, that's why you have to deal with in matrix form. So I will just give you a brief idea about how to write these notations and how to use them. So let me first write about the variance covariance matrix. So this, suppose there is a matrix. There are two assets, asset 1 and asset 2. Asset 1, asset 2. So this one, 1, 2, 2, 1, 2, 2, right? Where I into I is the variance and I into J is the covariance. Right, so that is what it means. Because we are modeling the volatility, so the dependent variable in this case is the variance. Just like in Garch model, also you have taken the variance as the dependent variable, right? Which is the same concept, same idea that we are now extending to in multivariate setting. Okay. So in statistics, you must have learned about how to calculate the variance. So suppose I into I, right? So it is basically equal to x minus x bar whole square divided by n minus 1. So this is the variance of that particular series. And it is I and j, it is equal to summation x minus x bar into y minus y bar whole divided by n minus 1, where n is the number of observation. Right? So it is the same concept we are applying here. Right? So that's why it is the variance covariance matrix. Have you noted down?
Yes, sir.
Okay. So next is the residuals part, right? In the residuals, I have written epsilon t minus 1, epsilon t minus 1 transpose. So that means, so this matrix is basically T into T minus 1, T minus 1 transpose. Right? So it is basically a squared residual. Now, if you observe it very carefully, so it is actually equal to E minus 1 whole square. And in the dependent variable, we have seen that it is a variance. Variance or the covariance, right? So this ij we are writing square is a function of this one. So if you observe it very carefully, it is very similar to your Lagrange model, because here we are adding another variable, that is this T minus 1 is also added, which is again the variance covariance matrix, right? So in univariate setting, we have used this. It is the same concept, right? It is the same concept that we are going to apply. Now, the first thing that you have to do here is that just for arch effect in multivariate setting. That is step number 1. Step number 2, arch is present, then model the variance using right or the big models. So that means in any case, we have to test for the presence of arch effect in the data, in the multivariate data this time. And this is the whole idea. Have you noted down?
So can you please explain this equation, sigma iz square?
This one, which is written.
Yes,
This
sir.
one. Okay. See, this equation is actually coming from here only. Right now, what is happening here is that this is a variance covariance matrix. This one. ठीक है?
Yes, sir.
तो अब इसमें हो ये रहा है कि suppose now suppose there are two assets, say 1 and 2. So you can say that this is the variance of the two assets. This is the covariance basically. ठीक है?
Yes, sir.
तो इसको स्क्वायर, ये वाला हम उसको कोवेरियंस मान लिए. तो दिस इज कोवेरियंस. ऐसा लिखेंगे, इसका मतलब क्या है? इट इज माय वेरिएंस, बिकॉज इट इज ऑन द सेम स्टॉक, राइट?
Yes, sir.
है ना?
हाँ जी.
So it is saying that it's dependent on its lagged value. Now, if you remember the Garch equation हमारा कैसा था? It is equal to omega plus sigma t minus 1 whole square plus this is alpha plus beta into t minus 1 whole square. Do you remember this is the Garch 1-1 model?
Yes, sir.
अभी वही चीज कर रहे हैं. Here also you are doing the same thing. The only thing is that it is a matrix now because there are two assets. So variance of asset 1 and variance of asset 2 is my dependent variable. Yeah. Then this one lambda
Yes, sir.
minus 1 है, variance 1 t minus 1, variance 2 t minus 1, ये हो गया। तो अब इसको मल्टीवेरिएट सेटिंग में एक्सटेंड कर रहे हैं। Part and this part. So this is this one. ठीक है, what is the additional part? Minus lambda. यहाँ हमने बीटा को रिप्रेजेंट किया और बीटा you can say it is an equivalent to 1 minus lambda in this case in a guard setting. So this factor is what? Et minus 1 and et minus 1. Et minus 1 and et minus 1 transpose. Basically it is equal to et minus 1 whole square. Right? So if you add 1 minus lambda, so basically it is et minus 1 whole square for the first asset and et for the second asset t minus 2 whole square. So it is the same model. It is only the guards model, but in a multivariate setting. But this is the way of representation.
Okay, sir.
I know. So this is my exponential weighted average moving moving average model. So once you are ready with this, so let's start our analysis. The first step is you have to first find out whether there is any arch effect in the data or not. Right? If arch effect is not there, so obviously Beck model and EWMA model is not required. Right? So we can go for a conventional standard deviation or variance. So let us do that first. So we have our returns already already with us. Okay. Now the command that you have to write is these three commands. I'm sharing with you in the chat box. But you have to run the library MTS first. So run library MTS. So the first part is to set the var model because it's var setting only again. So this is the var model and the result will be getting like this. Note it down, complete it, this part. Okay, यहाँ पे? These three lines.
Yes, sir.
First you run the first line, get the output first, then we will interpret this result.
Yeah, done.
Okay. Now see, variance covariance matrix is available to us, right? So we have the series, so we can calculate the variance and the covariance. But we need to estimate this error term. Error term is estimated using the I've written here. This is the residual of the mean equation. That means we first have to extract the mean, the residuals from this. So I'm just telling you the algorithm behind this. So what is happening here? So what you have to do here is, first we need to calculate the residual, those error terms, epsilon terms, you have to calculate. So for that, what you will do, you have to predict the mean value, the long-term average, which is equal to, let's say, well, let me write a constant plus alpha 1, say k, or maybe say zt minus 1, where zt is the return series. Right, plus the error term. So this is the equation we know. So the return of a particular series, this one R, is a function of its past value. So it is basically an AR1 model. Right, or if I make it more clearly, so what we have been doing, so write yt is a function of alpha 0 plus alpha 1 yt minus 1 plus the epsilon term. If you see it very carefully, it is basically AR1 model. Right?
Yes,
So
sir.
this epsilon term will be equal to then this minus alpha 0 minus alpha 1 into yt minus 1. Right? So this is how we will estimate the error term. So this is my actual value and this is my predicted value. So the difference between those two is my residual. So basically we are doing the same thing again. So we are extracting the residuals from its average value, from the mean value, and then we are using that mean value in our model, EWMA model. Right, so have you noted down? So should I proceed?
Yes, sir.
Okay. So let's go back to the result. This is the AR1 matrix you are able to see. And this estimate we also need to note down. Right, so can you take a this output? You can tell me. Up to this point is so sufficient. Just take a photograph of this one. Okay. So let me write the, are you getting this result, right? So let me write the model. So this is basically the mean equation, which is, now here we have to assess Bajaj return. So this model is actually equal to Bajaj underscore ret time period and NTPC underscore ret. So this is my return of respective series plus. It should be equal to the constant, the intercept. Intercept you see at the border, at the top it is written estimates. Estimates are 0.00161 and 0.003. How much it is? 0.0034. This is my constant term, alpha 0. So this is yt is equal to plus yt minus 1, right? T minus 1, the coefficients are minus 0. Just a second. Let me make some space. So it is plus. Let me make some space here like this. Since it is AR1 model, so it is Bajaj return. So minus 0.0094 into Bajaj T minus 1. And then we have 0.403 of NTPC return T minus 1. And here also you will have two values, minus 0.00675 of Bajaj T minus 1, and here it is minus 0.0183 into NTPC T minus 1. So this is basically by multiplied by RT minus or YT minus 1. So this is basically equal to YT minus 1. So this is the same equation we are writing, but in a multivariate setting. Yeah, are you done with this part? If any question is there in this. Yeah, should I proceed?
Yes, sir.
Yeah, go ahead.
Okay. So now, once you have identified the residuals, so I need to do some statistical test of the arch effect in the residuals. Right. If arch effect is present, then yes, I can go for EWMA model. So next line is basically you are extracting the residuals from the previous model, the VAR model. So let us run this. And the command is march test. March test for arch effect in the residual series. So are you getting this result?
Yes, sir.
So we can pick any one of them. So first one is the LM test. We have been doing Lagrangian multiplier test. and the p-value is 0, which means that you need to reject the null hypothesis of no arch effect. That means you conclude that yes, jointly also if the two assets are also combined, then also arch effect is present, and that is what we typically found yesterday also. Individually Bajaj return and NTPC return, they had some arch effect. So when we are combining them in a multivariate setting also, we are saying that yes, arch effect is present. So that means it is feasible for us to now try for multivariate volatility models. Right, so that is the conclusion of this particular test. So once you are sure that yes, it is present, then now let us go for estimation. So just I'm giving you this particular command. Just copy it. Let us run this line. M2 we have already taken, so let's try M3 here. And let us run this. It is 82, right? It is 82. Just check this one. Because 82 we have taken here. So here also it has to be 82.
So,
Yeah.
sir, and the command that you have given in line number 746.
746, okay.
So what is this for?
It is fitting a VAR model.
Why we
No, this is setting a vector autoregression model on the variance, not on the return series. Return series के लिए yesterday you have done that, right? The VAR model and VAR select and everything we have done for the return series. But for volatility, for variance, this command has to be used. MTS is basically multivariate time series. So all the multivariate computations will be done here. Am I clear?
Yes, sir.
Okay, great. Please, इसको run किया आपने M3 run हुआ? You see the value of this lambda is always 0.9, close to 0.97, and that is what our condition is also, right? Lambda should be less than 1, but it should be greater than 0. So lambda you have estimated now 0.97. इसके बाद तो आप इसको एक्सेल में भी कर सकते हैं, आपके पास लैम्डा का वैल्यू आ गया, right? The residual series is also there, so we can do it in Excel, but yes, why to do that when we have data with us? So finally, so this is the model fitting, right? So this is basically the model fitting to estimate lambda.
Can you please reshare the command?
Achha, this one?
Yes, sir.
ठीक है? So now we can see Now let us see, when we have fitted this particular model, let us see how our variance looks like, right? So whether we have been able to capture the volatility or not. So that is what we want to see. And once you have fitted the model, what is the next step? Again, you have to test for the residuals arch effect, right? So that you can improve now. Here is arch effect is present. So here now the third step is fit the model, and again test for arch effect in the residuals. If arch is present, so you need to, it's not a good model. So model is not able to capture clustering. So that means 2 times you are doing the arch test. Once before the model fitting and after the model fitting. Right. Yesterday also we did the same thing. Before the arch model, you tested for arch effect, and again you tested for the residual arch. So the same process we are repeating here. So since it is a variance covariance matrix, we are able to generate. We can have different plots also. 3 plots will be generated for 2 assets. First one is the volatility or the variance of NTPC. Second is the variance of Bajaj. And third is the covariance of both NTPC and Bajaj. These 3 graphs we can plot. Right, so it's a time varying plot you will be able to get. Right, so so let us see. So once you have fitted the model, let us select the margins. Okay, here. So we are having 3 columns, right? Or 3 rows also we can take. 3 rows and 1 column. Okay. Here there are 4 columns. The result, this result will always give you the 4 results, right? Let me show you. Okay. Here you see, you are able to get 4 columns. Right? The first column belongs to that. It is basically the variance of that asset which is written in the first in the data frame. So Bajaj. Right? So the first column is the variance of Bajaj. 4th column is the variance of NTPC. And 2 and 3, they are the same columns only. This is the covariance between the 2 assets. So आप कभी-कभी DCC guard आप use करते हैं for univariate setting. So here you can plot the EWMA also on a time varying basis. So you can see the covariance of the 2 assets on a time varying basis. Okay, so what you can do here, so first one is Bajaj. Right? The first plot is of Bajaj, so let me write it here. This you have to write. So write 1. And if you want to segregate, just type main equals variance of Bajaj. Let me copy this first, paste it here. Then 4 variance of NTPC. And if I write 2 here, it is the covariance. So 3 plots are ready with us.
Can you just give the commands in the chat box, please?
Sure. So it is M3 you have to write. M3 here, M3 here, and M3 here. Okay. So this one, this. So these 3 plots you will be able to plot. So you have extracted the time varying volatility also using the EWMA model. Are you able to get the plots?
Yeah, that's right.
Okay, so these 3 graphs you'll be getting. So these are basically the time varying variances. So what you observe that somewhere here the variances were very, very high, right? Maybe during the pandemic it was. And this is the covariance, right? Almost similar kind of pattern.
But more volatile, I think, no, compared to
This is
Bajaj
during
Finance.
pandemic 2019.
Yeah.
Is that okay? Okay, so and finally this command you have to write to test for the arch effect in the fitted model. So I'm sharing this again in the chat box. and this result you'll be able to get. Just check in your system, you'll be able to get this result.
Yes, sir.
Okay, so the p-value is still less than 1%. So you reject the null of no arch effect in the residual. That means your model is not appropriate. So EWMA model is not appropriate for Bajaj and NTPC. Okay, it's clear.
Sir,
Yeah,
so how we have fitted the model?
the model has been fitted now. So this is the graph you're getting. This is the variances.
Actually, in the earlier cases, when we were fitting the model, we have identified the lags and we have written those lag numbers in the model.
No, that is for the VAR model you have done.
Or it may be the ARMA models also. But in case our model is, sir, can you scroll up your window? So here our model is in 751 line.
751. This is my fitted model. Using a lag of 1 I have done.
Okay, so and how we have decided this lambda?
So this is an arbitrary kind of thing. So value reporting, if you want to see, I think somewhere they report it also. The lag. Because I just wanted to have a very smallest possible and to check whether it is able to do that or not. So in this case, what is happening? So it is not the lag. We have started with an arbitrary figure. Yeah. So this one we have started with as an arbitrary value, right? Unlike in CARS model also, we did not have any kind of lag identification mechanism.
Yes, sir.
And it is the same thing, same process. So we are starting with 1. If it doesn't fit, then maximum we can go up to 2 lags. Again, check. But the EWMA model, if you see very carefully, I mean, it's a very, very composite model, right? Only 2 parameters are to be estimated, error term and the value of lambda. Lambda in any case is constant.
Sir, in simple model, or I can say univariate models, we have checked for the, we tested the variables first, then we fitted the model, and then we tested for the residuals.
Residuals arch test, yeah.
Yes, sir. But in this case, we have started with the residuals. Like in 746, you render this var.
See here, no. In the GARS model also, na? We did not extract we extracted the residuals of the variance model. GARS में आपने जब बनाया होगा model, so this is the model, right? Equal to omega plus say alpha into this minus 1 whole square plus beta into this minus 1 whole square plus the error term. This is what the model is. It is my GARS 1.1 model.
Yes, sir. Yes.
What we have done, first we have fitted this particular model. Then we have extracted the residual here. And then we tested the presence of arch effect on this residual.
Yes, sir.
So this residual is still having arch effect. That means your model is not good. have to then refine. So you have used a standardized residual function, right? You have standardized it, then you have calculated the arch test.
Yes, sir. Yes, sir.
Got that. It's the same thing we are doing.
Okay.
Okay, so finally, what you are getting as an output?
So p value is less than 0.05.
Yes, here it is, no? Less than 0.05. So you say that your arch effect is still present in the residuals. So which means that EWMA model will not work in this kind of in these two assets. Is it clear? Yeah, any more question? No?
Sir, in the last command, what is the sigma dot t?
This is the variance we are extracting from the model.
Okay.
आपने यहाँ से वो किया ना? This one. ठीक है, तो it's
Yes, sir.
basically
Yes, sir.
हाँ, तो वहां से हम उसको एरर टर्म को निकाल रहे हैं, एक्सट्रैक्ट कर रहे हैं. So 82 you check. What is 82? It is basically the residual, right?
Yes, sir.
तो उसी को हम टेस्ट कर रहे हैं. Residuals. Okay, no problem. Please go ahead. Thank you. Thanks for coming. Right. I think he has left. Anyway, okay, so that is what we have done so far. चलिए यहाँ तक clear हो गया?
Spillover will take time, sir.
Spillover is just a discussion. I mean, I'm not going to talk about the modeling part. Just with a data set, maybe this Bajaj and NTPC only we can calculate, or maybe Microsoft, and then we'll talk about the output and the interpretation part.
Okay.
So, because I thought, let me give you an idea about how to interpret the results. Model expression you will be able to get in any case, but output will be important for you. So I thought, let me discuss that only. Okay, and finally the bake model. This model is quite complicated, right? Let me first write the equation. Say this again, the variance covariance matrix. It is equal to, let me write C transpose C. I will tell you what these C values are. Plus A transpose U T minus 1 U T minus 1 transpose A plus B transpose T minus 1 into B plus D transpose mu T minus 1 transpose and D. So this is basically the bake model, where as usual this is the variance covariance matrix. right? A, B, C are mean coefficients and nu is basically an you can say it is a variable which captures presence of asymmetric effect in the data. This will be equal to t minus 1 should be equal to t minus 1 divided by I. These complications for expressions right. So this I is basically an indicator variable. It is equal to 1 if negative news, 0 otherwise. That means this particular term helps you to understand the impact of negative news on the volatility. And I will not talk about this one. This is basically an Hadamard product. So this is in matrix notation, but I will split this equation for you to understand the interpretation part and the output. Right. So this is just a matrix notation. So let's see. Have you taken down these values? Achha, it is highly possible that if you run Beck model today, maybe because it takes time to estimate the results, it may take half an hour or 1 hour, you don't know. That depends upon the calculating power and the processor speed. Right, so this estimation may take time. So it's possible that once we execute this command, we may not immediately get the output. So what we can do in case we get the output, we can make interpretations immediately, but in case it is taking too much of our time, so I will just tell you the segregated part of this so that once you get the results, you can correlate. In the output also, you will get the same notations. That's why I have used these notations so that you can correlate directly. Right, so let me make a segregation of this particular model. Suppose I want to predict the variance of the first model, first asset, say 1. So it is equal to, you will be getting a result like this, C11 square plus A11 square term U P minus 1 whole square, where U is the error term, plus 2A11 into A21 into U1 T minus 1 U2 T minus 1 plus, it's a very complicated model, A2 comma 1 whole square is U2 T minus 1 plus 2 1 1 to B21 sigma 1 2 T minus 1 plus B21 whole square sigma 2 T minus 1 whole square plus D11 whole square new T minus 1 whole square plus 2D. This 2 is coming from because 2 assets we are using. So if we are using 3 assets, so this will be repeated 2 times, this expression. So this expression will become even large. 1 1 D 2 1 new 1 T minus 1 new 2 T minus 1, and finally D 1 whole square into new 2 whole square T minus 1. So this is the model only for 2 assets. So
Sir,
what happened? Yeah.
sir, it's not visible in the third line at the end, right?
Which one? This one?
Yes, yes, sir. On the
Uh,
extreme right.
the extreme, this one, last one, right?
Yes, sir.
It is 2D11
Okay.
and D21
Hmm.
new of the first asset, new T minus 1, new of the second asset T minus 1.
Okay, new of the first asset T minus 1 and
And new of the second asset
T minus 1.
T minus 1, yeah. This is only one lag we are using, one lag and 2 assets. The number of, you see the number of parameters we need to estimate. It is basically equal to a square divided by a into k plus 1 whole divided by 2. No, this is not divided here. This has to be divided. So it is k square plus k into k plus 1 whole divided by 2. So it is 4 plus 6 by 2, that is 3. Equal to 12, 7. See, since we have 2 assets here, so 7 parameters we need to estimate. First one, second, third, 4, 5, 6, 7. It's a 2 assets we have, so this is for 2, so 4 plus 3, 7 it is. What makes it difficult is that the interpretation part, right? So I will just tell you what these values are and what you have to look for in the output. So you have to focus on certain aspects here, especially the B part. This is the standard deviation. Since it is 1 and 2, it is basically the covariance, right? And here it is the variance. So you have to estimate, or you have to interpret. First B, you have to estimate, or you have to interpret. Second D. So B will tell you what is the impact of the variance and the covariance on the variance of the particular first asset, say Bajaj. Right. So what is the impact of its own variance as well as its impact of the variance of NTPC? This B will capture that. So first B will capture the impact of variance, and second B will capture the impact of covariance. Since it is T minus 1, that means if covariance was very high, now here you see this entire value is always positive. That means if the covariance was high yesterday, So the variance of this asset will be high today, right? Whereas this one is also the variance of the asset, first asset only. This is the covariance, right? And this is the, sorry, this is the variance, not the covariance. This is the variance of second asset, and this is the covariance. So covariance is also positive. It's always positive. This is positive, and then you have to find out what is the value of this one. Suppose this is negative, for example, and this is positive. Variance is always positive. So your entire multiplication will become negative. That means what? The impact of this particular, so B11 is basically the variance of the first asset. So even if other asset is having a positive variance, the variance of my first asset will get negatively affected because entire product will become negative here. But here if you see this one, this parameter is also positive. So this is positive, this is positive. The multiplication of these two will always be positive. So impact of this parameter on the variance of the first asset is always positive. But this one can either be positive or it can be negative. Right? So this is the interpretation of the variance part. Second, you need to interpret the values of this D, which you will be getting in the output window. Now, what do they mean? See, new T is basically an indicator variable. It captures the asymmetric effect. Right? It captures your asymmetric effect. Obviously, if asymmetric effect is there, so this value will be equal to 1 because it's a dummy variable. When we say that yes, negative news is there and it's able to capture that, so we denote it as 1. 1 multiplied by D square, right, will always be positive. But if you see the asymmetric effect of both the assets separately, then you do the total multiplication again. So every time you have to see the what is the sign you are getting for these values. And depending upon the sign, you can estimate or you can say what is the impact on the variance of this particular asset. So this is only of asset 1 we are talking about. So the B captures the impact of variance and covariance. D captures the impact of the asymmetric effect of news on the variance of first asset. Right, so that is what it means. And finally, I can write the equation of the second equation, the second asset. It is 2t whole square. It is equal to C21 whole square plus C22. These are the outputs you will be getting. This is exactly the same format you will be getting the output. So if you note down this value, it will be very easy for you to interpret the results. Plus A12 whole square U1 t minus 1 whole square, right, plus 2A12 multiplied by A22 multiplied by U1 t minus 1 U2 t minus 1 plus A22 whole square U2 t minus 1 whole square plus B12 whole square sigma 1 t minus 1 whole square plus 2 D12, B22, then the variance part, T minus 1. So this is the variance part. And finally, B22 whole square, sigma 2 whole square, T minus 1. This is the variance, this is the covariance part. Now the leverage effect, the asymmetric impact. So D12 whole square, nu 1T minus 1 whole square. So this is the asymmetric effect of the first asset plus D2 to asymmetric effect of the second asset now, nu 2T minus 1 whole square, and finally the joint effect of the negative news. So 2D12, D22, nu 1T minus 1, nu 2T minus 1. So this will be your final equation. So the Beck model's interpretation has to be in these terms, only on B and D, because B will capture the variance part. So this will estimate, B estimates the effect of variance and covariance at T on the variance of asset at time T plus 1. And D estimates the impact of negative news on the volatility of asset. Right, so this is what Beck model is all about.
Sir, what about the A?
A is a constant term, it is a mean. So it is not to be interpreted. It is just the intercept. Every equation has an intercept, so this also acts as an intercept only.
C and A both are intercepts.
C and A. C is the coefficient and A, because इसमें आप देखिए दो पार्ट है इसमें, एक C है और आपका A है, right? A is related to the past error term. तो past error term का कितना impact दिख रहा है, that is one coefficient. And C is basically the constant term of this equation currently at time t. तो जैसा आप इक्वेशन रन करते हैं तो alpha 0 is equal to alpha 0 plus alpha 1.
Yes.
So C is basically the alpha 0 part.
And A is alpha 1 and it is showing
Alpha
the
1,
past error terms.
Alpha 1 based on the past error term.
Yes.
So it is very similar to your exponential guards and GGR guards model. In univariate setting, we were using E guards and GGR guards to capture the leverage effect. है ना? And here we are using this additional parameter D to capture that leverage effect in a multivariate setting now. Okay, have you noted down?
Yes, sir.
Okay. So you see, only for two assets, you have so many parameters to estimate, right? If you include the third, for example, asset, the model will be even bigger, right? So it will the number of parameters to be estimated bigger increases exponentially, and that is the reason that Beck model is very complicated to estimate as well as to interpret, right? So that's why we can use a Cholesky decomposition, which is more compact, or like in the previous case we have done EWMA model, right? So that model is preferred, but many papers also report the Beck results, so there is no harm, but the model will be too complicated, right? So that is one of the fallouts of this particular model. So let me just show you. So what you have to do here is, the command is very simple. Just a second. Okay, so let us write our data that we are going to use is Bajaj and NTPC return. So the command is Beck 11. Right, Beck 11 basically it considers only one lags in both the cases, because we have seen that if we go beyond one lag, it becomes very complicated, right? So by default, the package also doesn't allow you to compute even beyond three assets. So here you can write Bajaj NTPC return, that's all. So I don't know how much time will it take, but still you can run this. You can check in your system. If anyone is getting the result, let me know. Because it will take a lot of time. Or alternatively, you do one thing, you can run it at your home today at leisure. And then if you get the results, let's connect and let's discuss your results in that case. I don't know how much time will it take. It will take a lot of time. Is anyone getting it?
No, sir.
Oh, time लगेगा उसमें बहुत. So it's such a complicated model, no? तो पहले तो वो एरर टर्म को निकालेगा उसमें से by using the maximum likelihood method. Then एरर को फिर फिट करेगा मॉडल पे to make the estimates. So that's why it's such a complication. Let's wait for 3-4 minutes, maybe if it works. Are you getting it? Has anyone got
No,
the
sir.
result? No, no. Time लगेगा इसमें.
Sir,
Ah,
sir, if there is arch effect in multivariate
yeah.
and EWMA is not capturing the clustering, then we go for back models.
Back model. Then if because now back, this is the problem, right? So maybe you can try for Cholesky decomposition or other volatility models.
Okay.
Like there is another model called as VECH model. Not VCM, it is VECH. So that also, but that is also complicated, too many parameters to estimate. So from interpretation perspective, I will still prefer you should go use EWMA should be a first preference. Or try to, now since you have done so many things in these 4 days, so maybe you can try to understand Cholesky decomposition. So that is a compact model and more efficient. It will take time. Just try in your system, maybe right, or at home, just execute this command and just wait for maybe 1 hour or half an hour. So by the time you may get the results. Okay, in the meantime, let me talk about the spillover part. So right now, what I will do is I will go for return spillover. But for all your analysis, you should focus on volatility spillover, which is basically return square, right? Now spillover means it is also a dictionary meaning of dictionary meaning only that that how far it is traveling and how to what extent it is affecting the other market or the other asset. So for example, there are 2 assets or say you have 3 assets, Microsoft, you have Ford, and you have say Netflix. So let us say I want to understand their integration. So if there is a shock given to this or if there is a change in the volatility in Microsoft, so does this volatility gets transmitted to Ford or does it get transmitted to Netflix or Netflix is getting transmitted to Ford? So what kind of relationship am I getting? Or Ford is able to transmit the volatility to Netflix. That means when there is a change in the volatility of say Ford, for example, it directly affects the volatility of Netflix also, right? By a certain percentage, certain amount. So whenever we talk about spillover is basically a bi-directional kind of a multi-directional analysis of volatility, right? And you want to understand that yes, if there is a change, there is a shock given to a particular asset price, then which are the assets it travels to and what is the magnitude with which it affects them, right? So that is basically a spillover analysis. So many assets, for example, suppose you want to understand, and this is very useful in case of portfolio management. So suppose you find that yes, when there is a shock given to the US market, so SP 500 gets affected sharply, then how does it affect the Nifty 50? or how does it affect the CAC 40 of France, right? Or how does it affect any other stock market? So that means you can not only understand the correlation and integration among the assets within one country, but you can extend beyond the geographies and can understand that if there is a volatility change in other markets, then how does it affect the market in a different country, right? So for example, you want to understand the impact of crude oil or gold prices in the Indian stock market, right? So prima facie, we know that yes, we import a lot of gold as an Indian. So if there is an increase in the volatility, if there is an increase in the riskiness of that stock, so that will directly impact my market also. But what is the magnitude of that effect, right? So that is what we are trying to calculate through spillover analysis. So you can do the same thing here also. It is still calculating. Are you able to get this output? Anyone?
No, sir.
Okay.
No.
It will take time. In the meantime, you press this red button so that its computations will stop and you can do your other analysis. The library that you have to use is spillover here. And the first thing that you have to do, I'm just giving you these codes. Just copy them and we will estimate the results. Run these lines. So since I have taken the return series, so this is basically the returns spillover you are able to get. Are you getting this table?
Lower is largely for returns only, no?
It is only for returns we have done, but you can do it for return square, which is basically the variance, volatility. The same mechanism, the same process. Just check, are you getting this result?
Sir,
Yes.
I have run the command, but this result is not coming.
Okay. Can you share your screen? No, you do one thing. That red color stop is there, na? Just press that red color. First you press that. Now you run line number 529530. Acha, there is no package. It is not installed. Go to install first. Install spillover. Just wait. Now it's done. So line number 529 again. Oh, acha, capital S. Spillover capital S. It's not happening. Let me check. So you do one thing. After 5 to 9, you press enter. Create another space for writing a command. Write var est1 is equal to VARS. You write VARS small v. No, small v, small a, RS. No, first select the first one. From there, are you able to get var v? Type v. Just press V. No, just press in your keyboard V. No, in the keyboard you just no. While that list, now you type V. Select the second option. Then you copy that Microsoft, Ford, Netflix, entire part up to alert max. Paste it there. Run this. Now run number 532. Varest 1, right? Varest 1. Now run this. Okay, so what is talking about that Microsoft here and this table you see, right? So Microsoft is able to transmit, or because of the returns changes in Microsoft, Ford return is changing by say 3.5%. Right? It is in percentage. All these figures are in percentage. Total is 100% here. So the Ford return and Microsoft return, right? So it is affecting only 3.5%. So if there is a change in the Microsoft return, only 3.5% of that return is getting spilled over to Ford, as compared to in Netflix 5.27%. Right? Similarly, Ford, if there is a change in Ford, how much it is affecting? For Microsoft, only 3.9%, which is very, very small. Right? Is it clear? So this is the interpretation part of this spillover analysis. And similarly, you can do for others also. See from others. See from others means of these two assets combined, how much return is getting transmitted to Microsoft. Ford and Netflix together, they are able to transmit only 8.8% to Microsoft. Right, so this is Ford return. That means Microsoft and Netflix is able to jointly transmit around 5.2% here. And finally, we have Netflix, which is 6.9%, means Microsoft and Ford jointly are able to transmit around 7% of the returns to Netflix. Right, so that is the interpretation of this table. Right, so obviously you should learn about doing this on the volatility part, not on the return series.
So,
Yeah.
so for volatility spillover, what changes we have to make in our command?
You don't have to do anything, just make a square series. So write like this. So for example, Microsoft underscore ret underscore say volatility. So is equal to MSFT return to the power 2. That's all.
So basically, we have to calculate their return scares for all these three companies,
And
and
then
then
again you
combine those.
right. So combine the volatility and again run the spillover. So you'll be getting the volatility spillover in this case.
Okay, sir.
So this is one way of doing this, assuming that the expected value of return is 0. But there is another method to do that. So instead of writing this one, you can also write like this: Microsoft return. Let me write a bracket here. Minus mean of Microsoft return. This one, then to the power 2. So this will also calculate. So this is called as the demand variance. So that can also be calculated.
Sir, what were you saying that we are assuming expected value of?
Expected average, expected mean is 0.
Okay.
But in your statistical analysis, if you do a t-test of mean and if you find that no t is not 0,
Yes, sir.
then you should use this method, this one.
Okay.
So this will also give you the volatility. And then combine all the 3 assets or 4 assets, whatever you have, and then you run that. But the interpretation will remain the same in percentage terms.
Okay.
ठीक है, चलिए, so good. So I hope.
Sir, will you cover different methods of spillover, like Bruni-Kralik, TVP VAR, and the bold Hillmans?
Sorry, I didn't get you. What you're saying?
Will you cover the different methods of spillover?
No, not today. Maybe some other FDP will try. Right, but within say spillover also you can learn something. So what you will do, just try to learn it on. Also, you can also do the same things. Just type spillover. This double quotation you are able to see, right?
Okay.
This double hyphen. So here you will be getting all the functions. So suppose you want to predict, you want to go for the graphs, right? So net spillover is also available. Net means. Net means
Sir,
how
I
much?
am majorly concerned about two methods, Bruni and Kralik and TVP VAR.
TVT var, time varying parameter.
Yes, sir.
Acha. That's a very advanced kind of thing, in the sense that structural var and all those things we have to discuss for that.
Okay.
Right. So time varying var is nowadays it's very much in use. So it is good that we can discuss maybe some other day whenever you are free. Then we can connect again
Okay, sir.
to discuss this thing in detail. It will be good that if you can come with your own data set, so that we can discuss it there itself. Okay, so can we have your projects if you want to discuss your projects? We can do that. Whatever is suitable to you. Did you face any issue, or did you?
Should I share my screen?
Yes, yes.
Sir,
Okay, yeah.
so this is daily data of exchange rate,
Okay.
but I am not able to execute this command. exchange return.
Okay, what you are getting? Error term, error message.
This is, let me show. Okay, this no numeric argument to mathematical function.
Okay. Let me see line number 3 first. Execute line number 3. No, line number 3. Data is not, no, it is, I think. She said data is not available.
Sir, it was there. I don't know what is happening.
Maybe do one thing, just go to that Excel sheet again where the data is there.
Yes, sir. Just 1 minute. Select and copy. No?
What?
I have to select and copy.
Select there and copy here. Let me see, are you getting the data? You see, now it has come.
Yes.
Okay, ठीक है. Go to that command.
Then I create this variable.
You write it again. No, just remove that in line number 4.
Yes.
After dollar sign, you have written exchange rate, right?
Yes, yes.
That you remove exchange rate, you delete. Up to dollar, you delete. Again, press dollar sign. Select the second option. Now run this. And 5, line number 5. Achha, it is taking as a character. Okay. Do one thing in line number 4, just after equal sign,
Yes.
you write as dot numeric. No, not as dot, write data dot frame.
Sir, please repeat again.
Data dot frame. Then bracket. Close the bracket. Now execute this. Now line number 5. Line number 6. Okay, it is not able to calculate the difference also.
Yes.
Okay, do one thing. Just remove that diff part. Close, delete one. Log exchange rate. No, in the just write log के बाद एक bracket और दीजिए. One more bracket. Type exchange rate, exchange underscore rate. No, select the first option. First option. Then no. ठीक है. In the within the bracket, second bracket, after exchange rate, you write +1. Now run this. Achha, you send me the data. Let me just go through it.
Okay, sir.
You have that in Excel sheet, right?
Yes, sir.
You forward it to me.
Okay. And sir, I tried for monthly exchange rate also.
Okay.
So that was working. Let me just show you. Sir, are you able to see this monthly?
Yes.
Yes, sir. So in this case, I want to ask for ARIMA model. AR and MA model both were working. So
Okay.
based upon the RMSE, I choose the least one.
Okay.
So AR was having least RMS.
Fine.
I
ठीक
choose AR.
ठीक है. हाँ.
Then I have to run ARIMA also.
No, not required.
So this is not required.
No. ARMA is a bigger model.
Mhm.
So if you're getting AR1, then that's perfectly fine.
Okay, so then arch effect was present and I went for Garch. So in E-Garch, gamma was positive and GJR Garch, gamma is positive but value is 0.058.
Okay, so it's not significant.
Yes, so this model is also rejected.
हाँ.
So leverage effect is not present here.
Yes.
Then sir, symmetric, asymmetric Garch, my conditional and unconditional standard deviation are not same. They are coming to be different.
Okay, how much? First, you have to show me the result of Garch.
This one, sir?
हाँ. You run that line first. Both the line. हाँ, run the next line. Okay. नहीं, ठीक है. That's okay. Then you write, नहीं, somewhere there you write one command.
Sir, which?
हाँ, here you write, are you Garch?
Are you?
हाँ, उसमें unconditional variance select करना है. हाँ, type you.
Sir, I am not able to do.
हाँ, नहीं, यही you type करना. No. After the, हाँ, give one more. हाँ, type you. Press you. हाँ.
Yes.
So you हाँ, unconditional variance नीचे कहीं होगा.
Unconditional variance.
Of Garch fit 3. कितना है?
0.0045.
हाँ, तो इसका you take a square root of 0, right? SQRT bracket 0.0046. How much? So 6.7%. ठीक है. Now enter. Write one more line. SD bracket. Exchange whatever variable you have.
Sir, return or rate?
Return. How much? So there is a lot of variation.
Yes.
So I think symmetric Garch is not working in your case. So you can change the order. Do one thing. In after symmetric Garch, you have taken 1, 1. Let's try with 1, 2. And again calculate the, run all the lines. Line number 75. उसका स्क्वायर रूट लेके 0.0058 कितना हो रहा है? No, it has gone up.
Yes. Sir.
Okay.
All the three models are not working. E-Garch, GJR, Garch, and symmetric.
Is the residual? Have you done residual testing for the Garch effect on the models? No, is residual stationary? I mean, in the go scroll down. Garch fit 3.
Yes.
Garch fit 3 को यहाँ execute this line. Go scroll up in the output window.
So which column?
Just scroll up a bit. ये तो ठीक है, मॉडल तो ठीक है. ठीक है, you do one thing, you send me the data, let me see. है ना? It is the same data, right?
Yes, sir. This is monthly and that was daily exchange rate.
Okay. ठीक है, you send me and write the questions also, what the problems you are facing, so that I remember.
Okay, sir.
Maybe tomorrow I will send you
Okay.
the results.
And sir, one more thing, like
Yeah.
I tried for FIIs, monthly FIIs data.
Mm-hmm.
So FIIs was coming to be stationary.
Okay.
So that means I cannot go for that.
No, if it is stationary means you can always predict, no?
So sir, how to proceed in this case?
No, auto correlation नहीं है तो तब तो problem है.
If it is stationary, then we can run.
You can go for prediction, na? You can go for arch model and all those.
Okay. Only VAR will not be there. Arch can be there.
Arch effect you have to test. It's a univariate analysis you are doing.
Okay.
So arch effect you have to test. If the data is stationary means it's perfect.
So many
Non-station-
times I face this problem, like the data is stationary at level only. In multivariate modeling, the
हाँ तो
data
ठीक है ना.
one or
So
two
you go.
variables, they come.
In that case, take the value as it is.
But sir, suppose I want to do VAR modeling.
So see, the idea is why we are doing out on return series, because return series are getting stationary. So whatever analysis you have done so far, that is after the confirmation that the data is stationary. So if you are getting the data stationary at level itself, like in your case you have got, so VAR model will also be fitted on the original data, because the data is already stationary, so you don't have to bother about anything else. हम प्राइस पे इसीलिए नहीं कर रहे हैं ना कि बार एंड गार्ड्स वी हैव नॉट डन, बिकॉज़ प्राइस सीरीज आर नॉन स्टेशनरी. सो नॉन स्टेशनरी में तो वो मॉडल फिट नहीं होगा. बट इफ द डेटा इज ऑलरेडी स्टेशनरी इवन विदाउट डिफरेंसिंग, then that data can be used for your modeling itself directly.
Okay.
ठीक है.
Yes, sir. Thank you.
Any other question or any other thing? So okay, so let me just understand from you how it has been. I mean, anything, any comment, any feedback you want to give? So that we can improvise in the next assignment. Yeah, madam, are you there?
Yeah, I'm there. No, I think it worked very well. The fact that you made us, the very next morning do it with more examples, that really helped. So that kept cementing what you thought one day. So I think it went off pretty well, if you ask me.
Okay,
Thank you so much for that. Yeah.
Anything you want to suggest?
No, not really. It's 4 days is long and taxing, but it's worth it.
Yeah.
And thank you once again. I'm sure for you it must be even more tedious. You've been talking for 4 continuous days. Yeah.
No. I'm used to this. But as a participant, I mean, since it is new to all of them, so you may face some issues. Doing coding, understanding simultaneously, it's a tough thing.
Yeah, but I guess what you said, so once we keep practicing, it will become that much easier.
Yes. Yeah. It will be it's very easy actually.
Yeah.
You must have observed that R does not have any say typical kind of programming.
And that's why it's simpler than the others. Yeah.
Right. And you can do lot many things. I mean, you can plot graphs. Graphics is very good in R. Right? You can also, especially in economics, you can always, there is a library called as ggplot2.
Okay, right, yeah.
If you can learn that, so you can go for, say, dynamic plots also, right? Suppose you want to show the population of Sri Lanka, India over a period of time. So in the same graph, you can change the color, you can show the impact, right? So those kind of facilities are available in that ggplot2. So the graphics is very, very good in R.
Okay,
Yeah. ठीक है. Yeah, Dr. Vemuri, any feedback or anything you want us to include or exclude, whatever?
It's very actually a very hectic workshop. Actually, I really enjoyed every bit of this.
Your voice is very, very
And,
feeble. We are not able to hear you. Maybe you can take out your headphone.
Yeah, is it okay now? Am I audible now?
It's better. It's better.
Sorry
Yeah.
for that problem. Yeah. Yeah, it was a very hectic scenario. I mean, you have really taken a lot of pains to explain each and every point over there, and writing on the board, and as well as again coming back to the coding. Coding was not very difficult, as you said. Actually, I had earlier also some experience, so coding was okay to me to some extent. As you said, ggplots is very good. Actually, I have also used it something. I feel actually one small PPT could have been better. I mean, some of these things, maybe we need to go both the things. That means the writing part as well as coding. But these kind of classifications, in case we are going for the model classifications, a small handout of maybe 5 to 10 slides, in case you show it beforehand, maybe it could have been faster to really accelerate our learning process. That's one dimension.
Great.
And the second is we have randomly taken, I do not know, I'm just guessing, is we have randomly taken this Microsoft, Netflix, and maybe some other companies, Ford and other things.
Yeah.
I think we have to go little bit known companies in the sense whether we can co-integration can be possible if some companies for some kind of exchange. Especially this is good for macroeconomics. If I really understand better, especially the inflation and whatever we are talking, I think it has got a great asset in case we start learning co-integration part. But we'll also help you out. It's not that we are, I mean, offloading from our side and passing it to you. That's not my intention of suggesting. We'll also work out on some kind of exchange rates, as maybe somebody was showing here today. And we'll see whether we can really develop that co-integration as a topic for next time. We can share it, some data for you, such that the new batch can be I mean, more useful to the new batch.
True.
But above all, actually, it is a very, very useful workshop for me. I have attended earlier some other workshops, but this has been really, I didn't know that this much depth is required to understand the background. And it was very nice. It was very thoughtful preparation. And I do not know whether economics is really working for you, whatever we have paid and whatever you have been really sharing. We are very much helpful to you. I mean, thankful to you and IMI also, and other people, whoever has helped in this particular MDP or FDP. We want to see you again very soon. Thank you very much.
Yeah, sure. So thanks for coming and thanks for participating. The participation is important. And all the 4 days you were here, so I mean, that's very important. So hope whatever you have learned, you are able to now apply in your own academic work, right? And let's hope that we meet again soon on any other platform. Yeah, Barkha, I mean, anything from your side you want to share?
So charges are really high. I think more people could take participation if you lower your charges.
Okay, no, actually, it is a 3-day program. Also used to be the same charge. So let me see if I can work out.
Yes, sir.
Okay, and the content part, etc. I mean,
It was really nice. As ma'am and sir has told, they have very well defined it. So I don't have any words.
okay, good. ठीक है. And Ria, both of your PhD students, so it will be very important for you.
Yes, that's why I was keen to join that, and thank God it is postponed. Like if it would have been on 17th, then I would not be able to attend.
Mm-hmm.
Yeah. So initially there was difficulty in coding, like on first day, but then we were used to this. So, and it was hands-on experience, so that was a good part. That was not monologue kind of FDP.
Okay.
Additionally, I would say that if you can include more contents like Bayesian var or Markov switching var, these type of,
Okay.
because we want to learn as much as we can from
Right.
you.
So I am floating another FDP somewhere in the summers on non-linear time series.
Okay.
So there will be talking about the neural network, your Markov switching models,
Okay.
right? TAR models. So those things are also going to talk about, and structural var also I will take up that time.
So that this was very nice, and thank you so much.
Thank you. Thanks for coming and participating. Hope you are able to now write some of the good quality papers and try to collaborate with your other colleagues, maybe in this FDP or in your institution also.
Yeah.
Right. So, Shelly, ठीक है. So thank you. Thanks for coming, and let's hope that we meet again very soon. Okay, so if you have any query or if you want to connect with me, just please let me know. Write a mail or you can directly call me so that we can connect at any point of time. Okay, so let's move on. And good luck to all of you.
Thank you, sir.
Thank you. Thanks for
Wish you the same.
Okay. Bye.